In this video, I'm going to demonstrate how to set up VM Manager to configure and maintain your operating systems that are deployed on your VM instances. So you'll see that I am in the dashboard for my web app application. The first thing we need to do is make sure the operating system API is enabled. So come up to the Search Products and Resources search bar, and let's just type in OS config API. And under Marketplace, under API, let's click the first result. There's a very good chance that your operating system config API is already enabled. So if you see it and it looks like mine and it says manage and try this API, then the API is enabled. If it isn't, you just click enable and wait, and then it'll be enabled for you. So once we confirm that our operating system config API is running, I'm going to go back and I'm going to come back into my web app dashboard. So now under Compute Engine, I'm going to come down and click the link that says Go to Compute Engine, and it's going to bring me into the Compute Engine console. You'll notice I have one virtual machine instance running. It's a Debian Linux instance, and it has no configuration on it. It's just been deployed. So what we need to do, over on the left navigation bar, if we scroll down, under VM Manager, we'll see OS Patch Management and OS Configuration Management. Let's go ahead and click the OS Configuration Management and come into the OS Configuration Management console. You'll notice that my instance is already listed under VM Instances, and there's no policies associated with it. So these policies are going to be used to install, remove, and auto-update software packages. And we can run these packages as needed or as soon as we fire up a new VM. So we're going to go ahead and create an operating system policy assignment. If you come up to your right, you can see some operating system policy examples. If you click that pop-up, it'll bring you into a GitHub directory where you can see some policy examples. They're written in YAML, Y-A-M-L. So we have a couple here: exec script Linux all, set up repo and install packages for Linux. So that's the one that I'm going to deploy. So I've downloaded this file to my machine, and now I'm going to upload it when I create my policy. So I'm going to go back to the Google Cloud Platform console, and I'm going to click Create Operating System Policy Assignment. So I go ahead and click Create, and now I need to give it an assignment ID. So I'm going to give it Policy 1 DEB for Debian, and it's going to be used to install content management packages on the operating system. So yum, apt-get, these type of things. So if we come down, here's where we can upload the operating system policy. So if we want to take a look at that operating system policy very quickly, you'll see here it is. So here's our operating system policy. It's going to set up the Google Cloud Monitoring repository, and it's going to install the stack driver agent for VMs if they're running Red Hat Enterprise Linux and CentOS. So for us, we're running Debian, but we will get the Google Cloud Monitoring repository. So I'm going to close this. I'm going to come down to the Upload OS Policy button. Now I have to browse for my policy file. So I'll click Browse. I get my pop-up window. I have it named os.yaml. So I'll double click to upload this policy. Then I'll come down and click Done. So you'll see now I have to target my VM instances. So what availability zone? So if I choose the availability zone drop down, I know mine is in US Central 1A. It's important to make sure that you select the appropriate availability zone that your instances are in. Now we get to the match operating distribution. So include VMs that match the selected operating systems. So I can choose all, I can choose Windows Server, Red Hat, CentOS, Debian, Ubuntu, SUSE Linux, or OpenSUSE. Mine is Debian, so I'm going to go ahead and choose Debian. Then I can come out, and you'll see once I click outside that under all operating systems, it's now set to Debian. Here's where I can include labels. So if my instances had labels like production for environment, I could add labels here to make sure this only rolls out to production environments. Or conversely, I can exclude labels, say environment production, and then it wasn't send out anything to these production environments. Now we get our rollout rate. So what's the increment of updates to do at a time and how long to wait? So this saves us from downtime. So a wave size of 10%. So do 10% at a time and then wait 10 minutes between updates. We only have one instance, so it's fine. It should be able to finish relatively quickly. So I'm going to click Start Rollout. You'll see the assignment rollout is started and now it's in progress. I can exit out the notification message and now I can come over and click policy-1-DEB, so the ID of the policy assignment. I go ahead and click it and it gives me a bit more information about it. So the assignment ID, the description, the revision ID, and when it was updated. And then I can view the operating system policy. So it's set up repo and install package policy. And if I click view, I can see this policy and what's happening. So I can come down, I can say the operating system is Debian, the ID was the setup repo, and the desired state is installed, and the apt package name was the stack driver agent. So I can go ahead and click close now. I can come back, and it'll probably take a few minutes, and as you can see, the rollout has succeeded. So we have rolled out the package management. So if we click the ID again, and click view again, you'll see that we have set up the stack driver instant for Debian. So I'm going to go ahead and click close and I'm going to go ahead and click back. So this was our operating system configuration management. But what about patch management? Do we want to set up a patching policy as well so we can update these instances as new patches come available? And of course we should. It's a great idea to do that. You can always keep up to date on the newest threats, and you can set up your patch management to happen during the nighttime or when people aren't using these machines. So on the left hand side under navigation menu, you'll see OS Patch Management. Come down and click it, and now let's start our new patch deployment. So under Dashboard, you'll see I have no operating systems being patched right now, and there's nothing under my VM instances because I haven't deployed a patch. So I'm going to come up and click the New Patch Deployment button. Now here's where we have an option. So do we select VM instances by filters or do we want to select them manually? If we have a lot of VMs, you're going to want to use filters. I'm going to go ahead and choose to select my VM instances by filter. I'm going to come down to Target Zone and I'm going to make sure I am in US Central 1A because that's where my instance is. I go ahead and click OK. Here's where you can filter your VM instances. So if I didn't want to patch every VM instance, I could put a filter in here and it'll only patch the specific VMs in that zone. I'm going to leave it empty. I want to patch them all. It's only one anyway. And we can also put a filter here on the container instances labels. So the VM instances that match the labels are going to be patched in the GCE instances. I'm going to leave them all alone because I'm going to patch just that one instance I have. So I go ahead and click Next. Now I give it a deployment name. So I'm going to call it Instance1 Deb Deploy. And now you come down under Advanced Patch Configurations and you'll see we're using Debian. So we want to expand the App Debian Ubuntu dropdown. And now what type of upgrades do we want to perform? Do we want to use an apt-get dist upgrade or an apt-get upgrade? I'm going to leave it as an apt-get upgrade, and I wanted to upgrade that full instance. So I'm going to go ahead and click Next. I can do it now, I can schedule it for later, or I can keep it on a recurring schedule. So if I click Recurring Schedule, under Frequency, I can do it monthly on a specific date, say the first date of the month, and I can choose 100 hours. For now, for this demonstration, I'm just going to click Start Now and click Next. Now we get the rollout options. So do we want to roll out one zone at a time or multiple zones concurrently? I'm only using one zone, so I'll use one zone at a time. And then the disruption threshold. So what's the maximum percentage of VM instances that may be disrupted at one time? So here it's 25%. I'm going to change it to 100 because we only have one. So I can disrupt that full one and just for demonstration purposes. I click Next. The post-patch reboot option. So I'm going to click it on default and let the agent decide if the reboot is necessary. There's also options for pre-patching scripts and post-patch scripts. So if you need to run some tasks before the patch, we can put it here under Linux script. Or if you need to run a script after patch, we can upload it here under Linux script. The options for Windows are also available too. I'm going to leave those alone. I'm going to come in and click the blue deploy button, and I'm going to deploy this policy. So as you can see now, my instance-1-deb deploy, the job is executing. I can click the job name and it expands, and I can actually watch the progress. So the job is executing. There's one instance being updated. The state is currently in patching. The percent complete is 50%. And you can come down and look at your zones and the percentage of VMs. So I'm going to go ahead and click close and just wait for this job to execute. So you can come up to the refresh button, click the refresh button from time to time, or you can come back and click the job name and just watch it at this point. If for some reason you did something wrong, you could just click abort this job and it would stop that patching job. I'm going to go ahead and click close, and from time to time I'm going to refresh. This may take upwards of 10 to 15 minutes. Conversely, if you wanted an even deeper dive into what's happening on your instance, you can click the instance name again, and on your sidebar pop-up you can scroll all the way down, and under updated VM instances you can see the instance name, the zone, and the status, so it's applying patches. So if we go ahead and click under logs, we click view, it brings us into the cloud operations logging console. And we can see everything that's happening with our VM right now. So the first entry in the log was beginning apply patches task. Then the system indicated a reboot is not required. Now it's updating 3 packages. So you can continue to click run query to view updates. And then eventually when it's done, you'll see that it is complete. Now I can run the query again. And now I can see that it successfully completed my apply patches task. So I'm going to leave. I'm going to go back to my compute console. Now if we can click close, and we're back to our main operating system patch management console. Come up and click refresh. And now you'll see that the job has changed to successfully completed. So let's click the job name. You'll see that it has been successfully completed. It tells you the name. It's succeeded. You can come down, and now you can see that it also says success there as well. I hope this video showed you how to use the Operating System Configuration Manager and the Operating System Patch Management to keep the operating systems of your virtual machines up to date and constantly patched. In this video, I'm going to show you how to manage a virtual machine instance by starting, stopping, and configuring our VM. So I'm under the VM Instances console menu in the Compute Engine console, and you'll see I have one instance running. It's just a basic instance of Debian, has some patch management software on it, and right now I want to show you how to make a few changes. So if you hover over the instance, you'll see this instance is running. So right now we have a couple of options. We can stop, make our changes, and restart the VM. So we can stop that VM temporarily if we don't need it, or we can restart it later. The stopped VM will retain its persistent disks, its internal IPs, and its MAC address, but it will lose its application state, and it will lose the ephemeral external IP. So I'm going to go ahead and highlight the instance I want to stop, and then I can come up to my title bar, and you'll see the 3 dots that represent more actions. I'm going to go ahead and click more actions. And I'm going to come all the way down and I'm going to select stop. This will stop my VM. So I get a pop-up, stop instance 1-deb. It just tells me that if I shut down this instance and it doesn't complete within 90 seconds, the instance will be forced to halt, and that can lead to file system corruption. Do I want to stop? I'm going to go ahead and click stop. You'll see the instance should go into stop state at this point. So once we wait, you'll see our little pop-up box on the bottom. It says stopping instance deb 1. And if you come all the way up to the top blue title bar, you can see under alerts it's spinning. And if you click the little bell, you'll see that it's stopping the VM instance 1 dep. So I'm going to click out of the notifications and back into my main console page, and I'll do a refresh. Once I do my refresh, you'll notice the instance is now stopped. The green checkbox is now a gray stop sign. So now the instance is stopped. I'm going to go ahead and click the instance name, and it brings me into details about this instance. So from here, I'm going to come up and I'm going to click Edit. This allows me to edit this instance. So the instance is shut down, and now I'm going to go ahead and change my machine type. So I'm going to edit the machine type from an E2 micro to an E2 small. I can come down. That's the only change I wanted to make. I scroll all the way to the bottom and I click Save, and it's updating my instance now. So this may take a little bit of time. You can see the Save button is scrolling through, so it's actually doing something. And you can come up under Alerts and you can see the edit of the VM instance, and it looks like it has been completed. So if I click my instance notification, I come back, the instance is still stopped. But if I click my instance name again and I scroll down, now you'll notice the machine type is E2 small, whereas previously it was E2 micro. So now I can come back up to my VM instance details bar, and I can start this VM right here. So I'm going to go ahead and click Start. It tells me it's starting the VM instance. I'll be billed for the instance while it's running. Go ahead and click Start, and now it starts your VM instance. So I always like to come back to the left-hand side on the navigation bar and click VM instances under virtual machines, so then I can get a good look at my instance and the status it's in. Now you can see the status turned to green, and now it's running. I can also do a suspension, so I can highlight the instance, I can come up to More Actions, and I can suspend the VM. So once I suspend the VM, it preserves its running state, similar to closing a laptop. You will be billed for the storage of the suspended state and the persistent disks, and nothing will change. So if I click Suspend now, it will just put that instance into suspended mode, and I can restart it just like I did a stopped instance. I'm going to go ahead and click Cancel. The last thing I want to show you is how to delete the VM. So up under More Actions, once again, we click those 3 buttons, and we come down and we select Delete. I click Delete. It asks me, are you sure you want to delete this instance? I go ahead and click Delete again, and the instance begins its deletion process. You can see the status changing. First it stops the instance, and then finally it will delete the instance altogether, and you won't see it under your VM instances anymore. So if I do a refresh now, my VM instances are gone. So I hope this video showed you how to stop a VM instance, edit that VM instance and restart it. I hope it showed you how to suspend an instance and the importance of suspending an instance versus stopping an instance, and finally how to delete an instance when you're no longer using it. In this video, I'm going to demonstrate how to update your instance using the gcloud command line tool. So I'm in my jump box. This is my workstation. Right now it's a VM in the Google Cloud platform, but it could also be just a Linux machine at home on your local desktop. So first thing I want to do is to look at the instances that is currently running and take a deeper dive into the instance that we want to change. So I'm going to type in gcloud compute instances describe web application. So web application is the name of the VM that we want to update. So I hit enter. It asks me, do I want to use the US Central 1A zone? Yes, I do. And now it gives me a full printout of this VM. So if I scroll up, I can look at everything on this VM right now. So right now it has a disk size of 10 gigabytes. If we come down to machine type, you'll see it's of an E2 small. There are other things we can change here. We can change IP addresses. We can change the network IP. We can change subnets. Okay, in this example, I just want to change the machine type to an E2 small. So I'm going to come down and I'm going to clear my screen. And I'm going to make a directory, and I'm going to call it app config. And that's where I want to export my configuration. So the next thing I want to do, I need to type in gcloud compute instances export. Now it's going to be web application, because that's the name of my instance. I have to put in my zone, so US Central 1A, and I have to give it a destination. So I'm going to give it the destination that we just created. So home, Rich Spencer, app config, and then I need to give it a name. So I'm going to call it web application. I hit enter, and it exports that pretty much the exact same text file we just looked at into a file that I can now edit. So let's take a look at that file. So I'm going to go into a text editor. I'm going to use nano. I'm going to say sudo nano home Rich Spencer app config web application. Now don't this look familiar? This is exactly what we looked at earlier when we did a describe on this VM. So we wanted to change the machine type. Now let's go all the way down till we get to the machine type entry. And I can scroll all the way over. I'm just using my arrow keys on the keyboard. And I'm going to change this machine type to an E2 medium. So I just erase the small, make it a medium. Click Control Save or Control S on the keyboard, and then Control X to get out of nano. So now we've updated it. Our last step now is to export that back to Google Cloud. So I'm going to type in gcloud compute instances, and now this time instead of export, it's going to be update from file, web application. I specify my zone again, US Central 1A. Now I have to give it a source, so that's the file we just changed. So source equals home, Rich Spencer, app config, web application. Now we have to type in our last parameter. It's most disruptive allowed action. Here's where I can type in 3 different values. So I can type in no effect, and this will just check to see if the request is valid and if the resources are available, but it doesn't actually do the update. Refresh will only run if the modified instance properties do not require the instance to restart. And we have to put in restart if the update requires the instance to restart. So in this case, we're going to put in restart. So if I go ahead and hit enter and we wait, at this point now it's sending the commands to the Google Cloud Platform, and it's updating that instance from an E2 small to an E2 medium. So now that you can see it has successfully updated, so we can run our gcloud compute instances describe web application command again, just to confirm that those changes took effect. So I click Y for the US Central 1 zone, and I look for machine type. I find machine type, and now it says E2 medium. So I hope this video showed you how to use the gcloud tool to export your VM configuration, update that VM configuration, then re-import it back to Google Cloud to make updates to your virtual machines. In this video, I'm going to show you how to SSH into your VM instances that are running a Linux operating system, and how to remote desktop into your Windows VMs. So you'll see I'm logged into my jump box. A jump box, I use it as a VM that I can kind of cross-connect with. So I put the jump box in a public subnet, and then everything else is usually in a private subnet, and I have permissions to SSH from the jump box to the private subnet instances. So the beauty with this way is that all the instances are on the Google Cloud network, and they'll share the keys back and forth. So when you generate a key, it spreads it out to all your Google Compute known hosts. So it makes it really simple to SSH in. So the first thing I really need to do, I can just type in gcloud compute SSH and the name of the instance that I want to SSH into. So in this case, it's instance 1, and I specify my zone as US Central 1A. I hit enter. It says existing host keys have been found in the home Rich Spencer SSH Google Compute known hosts. And now you can see that my prompt has changed to instance 1. So this is really it. I'm now SSH'd into the instance 1. Now that was an instance that was already SSH'd into before, and that's why it said these keys were already found. But what if it was an instance that has never been SSH'd into? How can we approach that, and how will it look any different? So all I need to do this time, and we can see the difference, is type in gcloud compute SSH, and this time I'm going to use instance 2, and I'm going to make sure I specify my zone as US Central 1A. So it's never been SSH'd into. Look at the difference. I hit enter. Now instead of it saying it found keys, now it's saying it's writing 3 keys. So it wrote the keys for instance 2 for me to use, and then logged me right into the instance 2. So you can see the difference. Next time if I were to SSH in, it'll tell me that it found the keys. Right? So if I type in exit and I type in the compute SSH again, this time it says existing host keys found. So it only needs to write the keys one time and pass it out to all the Google Cloud instances. Let's take a little look at this directory. So let's change our directory to home richspencer.ssh. And if I do a list directory, you'll see authorized keys, Google Compute Engine, then you'll see the Google Compute Engine public key and the Google Compute known host. So if I do a cat on authorized keys, you can see my authorized key. So there's the default key, plus there's the key that were created when I connected from the jump box. If I do a cat on Google Compute Engine, you'll see I also have a private key for the Google Compute Engine. So that's how we SSH in. We create a jump box, we create our local host. As long as it has the appropriate permissions, it'll create a key for us, spread it out to all the other VM instances, and then we can use this jump box to SSH in to all of our VMs that aren't accessible via the public IP. Next, I'll demonstrate how to log in to a Windows instance using remote desktop. So, unlike Linux, where you had to use SSH, Windows uses remote desktop protocol, or RDP. So, I'm going to go by RDP, and I'm going to click the drop down arrow, and I'm going to look at what options we have for connecting to a Windows instance. So first thing we need to do is set a Windows password. So I'm going to go ahead and click Set Windows Password. It tells me if an account already exists, resetting this password can cause a loss of encrypted data. So the first thing I need to do is give it a username. What username do I want to connect to this Windows instance with? So I'm going to use Rich Spencer. I'll go ahead down on the bottom and click Set. It'll set your username, and then it'll give you your automatic password. So it generates your password for you, as you can see here in the pop-up bar. If you come all the way to the right, you see the 2 squares. Click Copy, and you can copy your password. So at this point we set our password. I can go ahead and click Close. I can come back to my instance. On the drop-down, I can now choose View gcloud command to reset a password if I ever wish to. Or I can download the RDP file. So I want to connect. I'm going to click Download the RDP file. I'll get a download. It's an RDP file for Windows. I go ahead and click Save. I let it download, and you'll see it now. It's complete down in my Downloads bar. I'm going to double click it. Now you'll see Remote Desktop opens. It says the publisher of the remote connection cannot be identified. Do you want to connect anyway? We do. So I'm going to go ahead and click Connect. It auto-fills in my username. So Rich Spencer is my username. Now I paste in the password that I copied in a previous step. Now I click OK. You get another certificate error. So it just says there's no certificate and it's not from a trusted certificate authority. I'm going to go ahead and click Yes, I want to connect despite these errors. So I click Yes. It configures my remote setting, and it brings me into my Windows Server 2016 instance. So I hope this video showed you how to not only connect to a Linux instance, but how to also connect to your Windows Server instances as well. In this video, I'm going to show you how to create a VM with an attached graphical processing unit, or a GPU. So you'll notice I'm in the compute engine console of my web app project. First thing I need to do is come up to the top on the title bar and click Create Instance. So the process is very similar to creating a normal instance, but you'll see one little part that we have to change. So I'm just going to call this Instance GPU. I'm going to put it in US Central 1A. Then under Machine Family, I'm going to come all the way to the right and select GPU. This will change my series to A2, and you'll notice it's on A2 high GPU 1G with 12 virtual CPUs and 85 gigabytes of memory. These run at very high cost. So if you do follow along and create this instance, make sure you get rid of it right away. It'll cost you almost $4 an hour. So let's come down. Let's take a look. GPU type, you'll see it's NVIDIA Tesla A100 and the number of GPUs. So I'm only going to set 1. You can expand the drop down and go up so much as 16 GPUs. I'm going to leave it on 1. I'm going to come down. I'm going to look at my boot disk. I'm going to click Change. And now I'm going to change the operating system to a deep learning on Linux, because a lot of these deep learning applications will use the GPU power to perform their deep learning. And I'm going to leave the version on the deep learning image base for CPU. And now I want to make sure I have a disk size of at least 50 gigabytes. In this case, I'm going to change it to 100 just to be sure. I'm going to click Select. I come down. I can leave all the other things default and go ahead and click Create. So now we'll begin the process of creating my instance GPU. So this instance GPU is in US Central 1A, and it has a deep learning operating system on an A2 series machine. Now that our instance is up and running, I'm going to click SSH to SSH into the instance and install CUDA. So I'll maximize my SSH window, wait for the SSH keys to transfer, then we'll go about installing CUDA. So there's a couple things we're going to have to do before we actually get to the install of CUDA itself. One of these things is we're going to do a sudo apt-get install, and we're going to install some tools and libraries. So freeglot3, freeglot3dev, libxidev, and libxmudev. So I go ahead and click Enter. I click Yes to continue. It unpacks all libraries, and then it finishes. Next, we need to do a sudo apt-get install software properties common. So we're just going to get some common packages here. So I'm going to click Yes, and it expands and it starts unpacking all these extra packages and repositories that we're pulling in. Now we need to do a sudo apt-get install, and we want to get the wget feature on our machine. So I type in Y for yes, and it installs wget. Now the reason we installed wget was because we are going to use it to go up and download CUDA. So I'm going to clear my screen so we can get a little bit better look at the command I'm typing in. I put in wget, and it's a developer download.nvidia.com account. So you're going to need a developer account at NVIDIA. So I'm going to go ahead and click Enter, and it's about a little over 2 gigabytes. So depending on your connection speed, it shouldn't take very long, and you should have it. So now it's been downloaded. You can see it's been saved. Now we need to unpackage it. So I'm going to run a sudo dpkg command to unzip this CUDA repo that we just downloaded. So it's 2.24 gigs. It can take a few minutes to unpack everything, so don't think it's not doing anything. In the background, it actually is. Now that it's done, you see that it says the public CUDA GPG key does not appear to be installed. To install the key, run this command. So I'm just going to simply run the command that's specified, and you can see it successfully adds the key. So our next step is to do a sudo add app repository and get all the contributing files. So the contrib distribution component is enabled for all sources. We do one final sudo apt-get update just to update everything that we just downloaded and all those packages. The update gets finished. Now we run our command sudo apt-get-y install CUDA. So it begins to install it. This can take upwards of 5 to 10 minutes, maybe faster, depending on the horsepower of your machine. But when it's done, we just have to make one simple change in our bash file and we should be up and running with CUDA. So now that everything has been expanded, you get your configuration for your keyboard. I'm going to select English US keyboard layout. So I'll go ahead and click enter. It comes back into more unpacking and preparing and installing. So sit tight. It should be done very soon and you should be all up and running with CUDA. So now we're back to our prompt. CUDA has been installed, but we have to update our path in our bashrc file. So I'll clear my screen and I'm typing in sudo nano home Rich Spencer bashrc. And I'm going to edit this bashrc file and I have to put my path in. So I'm going to come down somewhere down in the middle of my bash file and I'm going to insert these two lines. Export path user local CUDA-11.3 / bin : $path and export LD library path user local CUDA 11-3 lib64. So these should set my runtime environment. So I'll click Control S to save and Control X to exit. Now I need to reload my bash file. So I'll type in source.bashrc. And now, just to confirm that CUDA has been installed, I'm going to type in nvcc-v. Once I hit enter, I get my printout, NVIDIA CUDA compiler driver, already installed, 11.3, done. So I hope this video showed you how to create an instance with an attached GPU and how to go about installing CUDA to get started taking advantage of these additional GPUs in the Google Cloud Platform. In this video, I'm going to show you how to view operating system inventory using the Google Cloud Shell. So really, OS inventory management is used to collect and view your operating system details for your VM instances. The OS details can have the host name, the operating system, and the kernel version. So we're going to use the gcloud. So before we begin, we need to make sure we have the gcloud command line tool and we're running it as administrator. And you also need to make sure that you have the Cloud Asset Inventory API enabled in your project. So once the gcloud is set up and the Cloud Asset Inventory API is enabled, now you can begin to pull back your operating system inventory. So I'm going to run a command and I'm going to type in gcloud alpha compute os-config inventories list. Then I'm going to give it two parameters, location equals US Central 1A and view equals, and this can be basic, so only displays operating system information, or it can be full, so it gives you information about the operating system and the packages. I'm going to type in full and I'm going to hit enter. It says you do not currently have this command group installed. Using it requires the installation of components alpha. And then it pops up a new window and begins to install the gcloud alpha commands, as you can see here. Do I want to continue? I type in Y for yes. Now it's installing the gcloud alpha commands. So this is a prerequisite to being able to use the operating system inventory as well. So once it goes through the install component, we should be able to use the alpha commands, go back to our previous window, and start pulling inventory. You can see once it updates the staging area, then it installs the gcloud alpha commands, creates a backup, and then activates that new installation. Now it's just performing its post-processing steps and we should be good to go. So now you can see my update is done. Press any key to continue, and now I'm back to my main Cloud Shell. So I can rerun this command now. I can just click the up arrow on my keyboard and it'll repopulate my last command. Now I can go ahead and click enter and I should pull back my inventories list. So you can see I have two instances. The instance names, you can see the operating systems, what packages have been installed, the available package, the operating system config agent version, and the last update time. So this is a full view. If I wanted to just bring back the basic view, I can change my view to basic, and now we can look at what the difference is. So we don't have the installed packages or the available packages available to look at. So that's just the difference between the two views. I can also look at just specific VMs. So I can type in gcloud alpha, compute, OS config, inventories, describe, and now I have to put in the instance ID. So in this case, I'm going to just copy the instance ID of instance 1 image 1, paste it in, and then put in my location equal to US Central 1A, and my view equal to full. And now that pulls back detailed inventory data. So if I scroll up, just for this instance, I can take a look. I can see all the installed packages on this instance, the architecture, and the version. So you get a much more detailed look when you look at it via instance, right? And you dig down deeper into it at the instance level. So I can continue scrolling. I can see all the packages, any package updates available, the architecture, the host name, the kernel release, the kernel version, its long name, the OS config agent version, the short name, the update time, and the version number. So there's a lot of details available when you just dial in on specific instance. Another thing we can look at is vulnerability reports. So I can type in gcloud alpha, compute, OS config, and this time I type in vulnerability reports, list, and then I specify my location of US Central 1A, and now it should pull back a vulnerability report. So I get an instance ID and a vulnerability count. So I can take this one step further again, like I did with the operating system inventory, and I can say gcloud alpha compute OS config vulnerability reports, and now I'm going to dial in on one specific instance. So I'm going to say describe. I'm going to paste in my instance ID again and my location of US Central 1A. Now I hit enter, and it gives me a deeper dive into the vulnerability report of this instance. So I can scroll up, I can look at all the details and all the vulnerabilities that may exist on this virtual machine. So I hope this video showed you how to perform operating system inventory on your VMs, how to drill down into specific VMs, and how to also look at vulnerability reports using the operating system inventory tool on the gcloud shell. In this video, I'm going to show you how to create, view, and delete snapshots. So snapshots are persistent disk snapshots, and you can use them to periodically back up your data from zonal persistent disks or regional persistent disks. So you can create snapshots when the disks are attached to running instances. It's important to note that snapshots are global resources, so you can use them and restore your data to a new instance within the same project. And you can also share snapshots across projects. So in this case, I have instance 1, and I'm in the compute engine for my web app. I want to create a snapshot of instance 1. So I'm going to come over to my scroll bar, I'm going to come down to storage, and I'm going to select snapshots. Here's where I can create my snapshots. So you'll see I have no snapshots here. I can create snapshot schedules if I wanted to create a schedule so it would snapshot on my schedule. Right. For now, I'm just going to come up under snapshots on the snapshot bar and click create snapshot. So I'm going to give it a name, and that name should appropriately reflect the instance. So I'm going to call it instance 1 snapshot. I'll give it a description. This is a snapshot of instance 1 for backup purposes. And now we choose our source disk. So you can select the drop down, and it gives you whatever disks you currently have available. So I have a source disk for instance 1 and a source disk for my web instance. I want to back up and take a snapshot of instance 1. So I'm going to go ahead and click instance 1. Now should this be multi-regional, so all of the United States or Asia Pacific, or should it be just regional, so US Central 1? I'm going to leave it on regional, and I'm going to leave it just in US Central 1. If I wanted to use this over multi-regions, then I would have to select multi-regional. I can come down, you'll see I can add labels. So if I wanted to say created by, I could put in Richard Spencer, just so we know who created it. Encryption will automatically be done, and it's Google managed. So I'm going to go ahead and click create. But before I do that, I can expand and look at what the equivalent command line would be. So here's the equivalent gcloud command line command. It uses the compute disks snapshot instance 1 command. So I can run that right now in Cloud Shell. I'm going to click close, come back down and click create. So I'm going to create this snapshot. So the length of time it takes to create the snapshot is heavily dependent on the size of your disk. This is a 10 gigabyte disk size. This snapshot should not take a really long time. So as you can see now, the snapshot has a green check mark. It's ready for use. So I can click the name of the snapshot to view more details about the snapshot. It gives me the description, the source disk, the disk size, what the snapshot size is, its location, any labels, the creation time, and the encryption type. And I also have the equivalent REST command here for it as well. So if I click the equivalent REST response, you'll see the equivalent REST response. I'm going to go ahead and click close. Here's where I can edit my snapshot. So if I click edit, I can change my labels. I can add labels. That's about all we can really edit. I'm going to go ahead and click cancel. And at this point, I'm happy with the snapshot. I'm going to go ahead and delete it. So once you don't need the snapshot anymore, I wouldn't recommend deleting it if you're using it for backup purposes. If it's an old snapshot, then you can delete it. I'm going to go ahead and delete this now for demonstration purposes. So I click delete. It asks me, are you sure you want to delete the snapshot? I click delete and it deletes the snapshot, and now the snapshot is gone. So I hope this video showed you how to create a snapshot from your instance persistent disks, how to view and edit that snapshot, and how to delete that snapshot in the Google Cloud Platform. In this video, I'm going to show you how to create, view, and delete machine images. So while snapshots are disk snapshots, a machine image can store all your configuration, the metadata, permissions, and data from the disks as well. So it's the full deal. It is your full machine image. So if you configure a machine and it's exactly the way you want it, you can create a machine image from it, and then all those settings are captured and you can redeploy it at will. So I have instance 1 and I'm going to create a machine image from instance 1. So I'm going to come over, I'm in the Compute Engine console, I'm going to come over to my scroll bar, I'm going to come down under Virtual Machines, and I'm going to click Machine Images. So here's where I can create my machine images and view any of my machine images. Right now I have none. So I need to come up on the Machine Images toolbar and click Create Machine Image. So this machine image is going to be an image of instance 1. So I'm going to give it a name of instance 1 image and a description. This is an image for instance 1. Now I get a drop down. What's the source VM instance? So I'm going to choose instance 1 in my drop down. It's the only VM I'm running, but if I had multiple VMs running, you would see them listed here. I'm going to choose instance 1. Now we choose our location. So should this be multi-regional? Do I want to use this machine image over multiple regions? If so, I'll select the region. So in my case, it would be US. Others, it could be Asia Pacific or European Union. If it's only going to be used regionally and I'm only deploying in US Central 1, I can choose regional. and the location is now set to US Central 1. I'm going to go ahead and leave it at regional at US Central 1. And now I scroll down to my encryption options. So I can use a Google managed encryption key, I can use a customer managed encryption key, or a customer supplied encryption key. I'm going to leave it on the default Google managed encryption key, and I'm going to come down and expand the show advanced information. So this show advanced information gives you a bit more properties, right? The machine type, the service accounts it's using, shows your boot disks, your network interfaces, all your deletion protection. So it shows you everything that you're setting on that machine image. I'm happy with the way it looks. I'm going to go ahead and click create. It'll create this machine image now. It's an E2 medium. So again, the machine type and the size of the disk is going to make a difference in how long it takes to create this machine image. An E2 medium should not be too long. Once it's complete, you'll see the green check marks. It says the instance 1 image is now ready to use. So if I click the image name, I can go in and view more details about this machine image. So it gives me its location, the machine type, any network tags, the service accounts that it's used. So anytime I deploy this machine image now, it's going to take all these properties. It'll take the service account, the machine type, my disk size, any data and configuration on that disk, my network interfaces, and all my available properties. So once I'm happy with my machine image, I can go back and come back under the main machine images console, and I can come under actions. So here I can create an instance from this machine image. So if I click create instance, it'll bring me into that instance creation page that we always see before, right? And we're very well used to from creating images. But you'll notice one thing has already been set for you. And if I scroll down and I look at the boot disk, it's a new 10 gigabyte balanced persistent disk from the machine image. So if I come down and click create, that will create my new instance called instance1-image1. So it names the instance based off of the image itself. So I can refresh. This is being created. In the meantime, I can come back to my machine images. I can find my instance image 1. And when I'm completely done and ready to delete this instance, I can come over to actions and select delete. It prompts me, are you sure you want to delete instance image 1? I do. So I click delete. And it begins the deletion process of that machine image. So I hope this video showed you the importance of machine images, how to create a machine image, how to view that machine image and launch a VM from the machine image, and finally how to delete your VM image. In this video, I'm going to show you how to create and manage instance groups. So an instance group is a collection of virtual machines that you can manage as one single entity. So Compute Engine has two different kinds of VM instance groups: managed instance groups and unmanaged instance groups. So essentially, managed instance groups are managed for you. Your workloads can be scalable, highly available, and can take advantage of auto-scaling and auto-healing. Or unmanaged instance groups that let you load balance across a fleet of your VMs. So I'm in my dashboard for my project. I'm going to come down and click Go to Compute Engine. So that'll bring me into the Compute Engine console. And from here, I can create my instance groups. So once I'm in my Compute Engine, I'll come over and I'll come all the way down on the scroll bar and I'll see instance groups. So I can expand instance groups and I can click the instance group link. That'll bring me into the instance group console. You'll see I have no instance groups right now. I'll click create instance group, and from here I can choose what type of instance group I want. So do I want a managed instance group that's stateless, a managed instance group that's stateful, or a new unmanaged group? I'm going to use a new managed instance group that's stateful. This is good for disk and metadata preservation, auto healing and updating, multi-zone deployment, and load balancing. So I'm going to come in, I'm going to change the name of the instance group, and I'm going to call it Instance Group Web Server. My location, I'm going to set to multiple zones. I want to load balance this web server. And my region, I'm going to change to US East 1. So here's my target distribution shape. How do I want to shape my traffic out when creating the instance groups? Do I want to make it even and distribute managed instances evenly across the zones? Do I want to make it balanced? So balance it as evenly as possible across zones, given the availability of resources in each zone. And any would deploy the managed instances to one or more multiple zones based on the availability of resources in each zone. I can come down and choose instance template. So right now I have no instance template. I have to create a new one. So I'm going to click create a new instance template, and I get a pop-up window come from the right side of my screen where I can create my instance template. The group will then use this instance template when it launches new compute instances. So I'm going to make it a general purpose E2, and the machine type is going to be E2 micro. I'm going to come down. I'm going to leave everything the same. The boot disk is the same. I'm going to make sure my service account is the default service account, and I allow HTTP and HTTPS traffic. I'm going to go ahead and click Save and Continue. And you'll see now the instance template is pre-populated with the instance template I just created. And if you scroll down, you can see all the information about it. So if I go ahead now and click Stateful, this is going to make it stateful. So if the instance gets deleted, detach the disk. I can also select the drop-down and make it delete the disk. So preserve the disk on VM recreation and updates, or detach the disk, we'll take it off that instance and put it on the new one. I'm going to leave it on as detached disk. I'm going to come down, and here's my auto scaling. So I want 2 instances, and I want a health check. So I can create a health check if I don't have any already. So I'm going to click Create Health Check, and I get another pop-up window. I can create my health check. I'm going to call it Health Check-Web Server. My protocol is port 80, and I want to check every 10 seconds. A timeout is when it doesn't respond in 5 seconds. A healthy threshold is 2 consecutive successes, and an unhealthy threshold is 3 consecutive failures. So I click Save and Continue. My initial delay will be 300. So that allows us to not perform any scaling actions. It gives us 5 minutes for the instance to come up and stabilize. So I'll go ahead and click Create. It creates the instance group, and it starts to actually create the instances as well. So you can see the group starting to be created. And once it becomes created, you'll see instances will be 2 because we asked for 2 instances, and the template will be the instance template we created. So we'll let this spin up, and then we'll check back in on the results. Now you'll see it has begun to start. It's going from 0 instances to 2 instances. Now you'll see Instance Group Web Server has 2 instances. So if I click the name, it brings me into a little bit more details, and you'll see that right now it is updating. There's 2 instances, and the instances are being verified. And that's why we need that 5 minutes between scaling activities, just to make sure that we give the instances enough time to come up and stabilize. So here I can edit, I can create rolling updates, I can come down to the next bar and check out some more details, any monitoring, and any errors that may be on the instances. So if I come back to Overview, I can come up to my title bar and click the back arrow to go back to the previous page. I can click Refresh. Now I'll see I have 2 instances running. So if I come over to my navigation bar on the left-hand side and click VM Instances, we should see 2 new instances called Instance Group, and in my case it's Web Server, and I have 2 instance groups, both in US East 1. One is in C while one is in D. So I hope this video showed you how to create and manage your instance groups, and to be able to spin up new instances automatically as needed. In this video, I'm going to show you how to create an auto-scaled managed instance group using an instance template. So I'm under the dashboard for my web app project. I need to go into the Compute Engine. So I'm going to come down under Compute Engine and click the Go to Compute Engine link. So once I click it, I'm brought in right into my VM instances for my Compute Engine. So we want to look at an auto-scaled managed instance group using an instance template. So let's come to the left and scroll down our navigation bar and let's find instance groups. So under instance groups, there's a link for instance groups. Go ahead and click that link and we're brought into our instance groups console. So you'll see I have no instance groups. Now I'm going to create one. So I click create instance group and I'm brought into that main console. So I'm going to call this ASG or auto scaling group instance group 1. Now my location, I want to have multiple zones so that I can load balance over multiple zones in a region. I can expand configure zones and I can check off every zone that I want to deploy to. In this case, I'm deploying to B, C, and F. So that's the ideal scenario, is that you deploy to 3 different zones when you're doing a multi-zone approach. That way, if you lose one zone, you still have that high availability. Next, we choose how we want to distribute our VMs over the zones. I'm going to choose even. We come down now and we specify an instance template. So we can use the instance template we created in the previous video, or I can create a new instance template. So if I click create a new instance template, this time I can call it ASG instance template. I'm going to leave it at an E2 with an E2 micro machine type. And I'm going to leave all the default settings, but I'm going to allow HTTP and HTTPS traffic. So I click save and continue. Now you'll see the auto-scaling group instance template has pre-populated. Now I'm going to scroll down and I'm going to set up my auto-scaling. So I can auto-scale. So it'll automatically resize based on demand. So if I have a lot of traffic, I'll scale out. If that traffic subsides, I can scale in. So under auto-scale mode, if we click the drop-down, you'll see auto-scale, don't auto-scale, and auto-scale only up. So to only add instances. I'm going to choose auto-scale. I want to add and remove instances from the instance group. So I choose auto-scale. Now you see the auto-scaling policy. So what metrics do I want to use to scale up and down? So I have a default setting of CPU utilization at 60%. So what that means is that if my VMs reach above 60% CPU utilization, I'll add more VMs. If it drops down below 60, I'll remove those VMs. I can change this metric. So I can click the pencil and I can change my metric type. So I can drop down and I can change it from CPU utilization to HTTP load balancing utilization to stack driver monitoring metric. So I'm going to leave it on CPU utilization and I'm going to change the target CPU utilization to 50% and go ahead and click done. I can also add a new metric. So those new metrics, I could add the load balancer utilization now, or I could add the stack driver monitoring metric. I'm going to go ahead and click the garbage can. I'm not going to add a new metric. I'm going to leave it on CPU utilization. Next, you come to predictive auto scaling. So predictive auto scaling is used to predict future capacity and future needs. We can't turn it on right now because we need our auto scaling to be running for at least 3 days so the Google Cloud Platform can pick up and identify our traffic patterns. Our cooldown period, so how long is it going to take for our application to initialize from the time we boot it up? We set it to 60 seconds. Our minimum number of instances is 1 with a maximum number of instances of 10. So I'm going to set the minimum number of instances to 3 because I want to take advantage of that multi-zone availability. I can enable scaling controls So that would prevent a sudden drop in the number of running VMs in the group by controlling the process of scaling in. So it's not just a constant scale in, but it's more of a back off scale in. So you don't drop a ton of VMs at one time. So I'm going to enable scaling controls, and I'm going to say don't scale in by more than 10% of the instances over a course of 10 minutes. I can change it to a number of instances, and I can change the duration. And really what this allows us to do is gracefully bring down our VMs and scale down a little slower, but it'll prevent that sudden drop. For auto healing, I can choose a previous health check, or I can create a new health check. So if I click create new health check, I'm just going to call it ASG-8C. I want it to check on port 80 every 10 seconds. So I click save and continue. My initial delay before the health check kicks in is going to be 300 seconds. Then I go ahead and click create. So now it's creating that instance group, and it should spin up those first 3 instances. So you'll see the instance group get created. Now you'll see that it's going from 0 instances to 3 instances because we specified at minimum 3 instances. You'll see now the 3 instances are spun up. And if I scroll all the way over, you'll see the zones, US Central 1, and it's in 3 of the 4 zones. So I scroll back over, it's still transitioning. Now you can see under auto scaling that it's on, and the target CPU is set to 50% utilization. So when I come over to VM instances, on our navigation menu on the left, when I click VM instances, I'll now see 3 instances spun up. So the naming convention is based off the instance group. You'll see 1 is in Central 1F, 1 is in Central 1C, and the last one is in Central 1B. And you can see that it's in use by an auto-scaling group instance group. So I hope this video showed you how to create those auto-scaled managed instance groups by using an instance template. In this video, I'm going to show you how to retrieve your default instance metadata from your virtual machine. So every instance will store its metadata on a metadata server, and then you can query that information from within your host instance and from the Compute Engine API. You can query for information about the instance such as the host name, the instance ID, and you can use this in startup and shutdown scripts. Your instance automatically has access to the metadata server API without any additional authorization. The beauty behind this is that the metadata server, when used in combination with startup and shutdown scripts, can be very useful to get unique information about an instance without having to go additional routes of authorization. So you could write a startup script that gets the key value pair for an instance's external IP, and then you can use that IP to provision a database. Because the default metadata keys are the same on every instance, you can reuse your script without having to update it for each instance. So let's go ahead and pull some information back. So the first thing I want to paste and get back is some information about the host name of my workstation. So the first command we're going to run is to pull back the host name of the instance. So I'm going to paste in my code, and now let's take a look at it. So we're just doing a simple curl -h. So we're passing in a header that says metadata-flavor::Google. So we need to include this with every request we send. Next, we put in the metadata server. So it's metadata.google.internal /compute metadata /v1 /instance and then /hostname, because the host name is what we're trying to figure out. So I hit enter and I get my host name back, richardworkstation.usd1b.c.mywebapp-314016.internal. So I get the full host name back. What if I want to, say, get something like ID? So I can put in the same code again, but this time I can erase host name, and under instance I can put in ID. Now it pulls me back my instance ID. I can also put my header in a different location. So if I wanted to do the curl first, and then I can specify my header after. As long as it has that metadata flavor Google, we're good. So in this one, I'm pulling back the compute metadata for the disks, and I'm specifying recursive equals true. And what that does is it returns all the contents under the disk directory. So I hit enter, pulls me back all my disks, says the device name, its interface is SCSI, and it's in read-write mode and is a persistence balanced disk. So I can do that same recursive with the instance, and I can pull back a ton of metadata for the instance. So I'll clear my screen. Then I'll come back up, and I'm going to come back, and under instance, I'm just going to say recursive equals true. Then I have to specify my header, metadata dash flavor, Google, and it pulls back all the metadata about this instance. See, these are directories, so instance would be a directory, and you can pull back things like disks, forwarded IPs, right? But if you want to pull back everything, you can just do a recursive equals true. So at this point now, I can pull in my CPU platform, my device name, my network, the machine type. I can bring back all this information, and then I can reuse that in a startup script, in a shutdown script, whatever the case may be. But Google Cloud makes it very easy for you to go in and pull metadata back from your instance and to be able to use that metadata to really make your architecture special and dynamic. In this video, I'm going to show you how to view your resource quotas and how to make changes and request quota adjustments from the quotas page in the Cloud Console. So I'm logged into my project 15695. This is not a free trial, so I can edit my quotas. When you're using a free trial, you can't edit your quotas. They're enforced by Google. You can, from time to time, request quota adjustments, but under a free trial, it may be a little bit more difficult. Now, once you get out of the free trial and actually start using Google Cloud in your organization, you'll be able to edit your quotas and request adjustments as needed. One of these adjustments could be to increase the number of VMs. So the compute engine will enforce quotas for various reasons. It'll try to keep, unforeseen spikes in usage against a multitude of users. And it can also, like mentioned before, offer free trial quotas that'll give you limited access to try out Google Cloud. So that kind of is part of the deal with the free trial, is there are some quotas behind it. So let's go over to our navigational menu and come in under IAM and admin and scroll all the way down to quotas. Once I click quotas, I'm in my quota menu and I can see all the quotas that I have enforced. So under the Compute Engine API, I have subnetworks, networks, subnetwork ranges per VPC. So these are all quotas. So there's a quota on the number of networks I can create, a quota on the number of subnetworks I can create. There's also BigQuery API, Cloud Trace API, and more Compute Engine API like in-use IP addresses, static IP addresses, and so on. So I want to look at the Compute Engine API for networks. So I want to look at all the quotas. So I'm going to click All Quotas, and you'll see right now my current usage is 1, my 7-day peak usage is 1, and I have a limit on 5. And this is a global resource. So this will be a global quota, not a resource quota. So I'm going to go ahead and I'm going to come up to the top and click Edit Quotas. From here, I can select what quota I want to edit. So I'm going to select the global network quota. My current limit is 5. Now I'm going to enter a new quota limit, and that request will be sent to the service provider. So I'm going to say 6. And I'm going to say as a description, we have a new satellite office and in need of another network. The more information you can give them with your quota adjustments, the better chance that you will get the approval and it'll do what you want it to do. So once you're finished, go ahead and click Done. You'll see the quota change. Click Next. You have your name and your email, and these details will be sent to the approvers while they review your quota change request. And you put your phone number in, and then go ahead and click Submit Request. So now you can see that I have submitted. There's a case number to Google Cloud Platform, and it tells you what you're trying to do. So you're trying to change your quota for networks from 5 to 6. So I hope this video showed you how to find your quota metrics, the difference between global and resource quotas, and then how to edit your quota to ask for a quota adjustment from Google Cloud for things like the number of networks that you can create or the number of IP addresses that you can reserve. So get in, look around at your quotas, and if you do need to, go ahead and request quota adjustments, because it's better to do it proactively than reactively. So in this course, we've examined managing Google Compute Engine. We did this by setting up VM Manager and managing and updating a VM instance, connecting to a VM instance with SSH and RDP, creating a VM with attached GPUs, using OS inventory management to view running VMs. We also created, viewed, and deleted snapshots and images, create and managed instance groups. We used instance templates and querying VM metadata, and accessing and requesting quota increases. In our next course, we'll move on to examine implementing Google Kubernetes Engine. Google Kubernetes Engine, or GKE. GKE provides a managed environment for deploying, managing, and scaling your containerized applications using the Google infrastructure. A Kubernetes cluster consists of multiple components working together. Configuring, securing, running, and maintaining a Kubernetes cluster requires a lot of domain knowledge and effort. GKE helps to mitigate the amount of domain knowledge and the effort required on our part, and that's by taking the responsibility for most of the system management tasks. Cluster orchestration with GKE. So GKE clusters are powered by the Kubernetes Cluster Management System. This is an open source solution. And Kubernetes provides the mechanisms for which you can interact with your cluster, so you can use commands and various resources. You can use Kubernetes commands and resources to deploy and manage your applications, perform administration tasks, set policies, and monitor the health of your deployed workloads. Kubernetes is designed on the same principles and platforms that run all your other Google services, and therefore you'll get all those benefits that you're used to. The automatic scaling, the monitoring, the rolling updates, and so much more. Some Google Kubernetes Engine features. So one of the features of GKE is autopilot mode. So this is an optimized cluster with a pre-configured workload setting, and it offers a nodeless experience. So with autopilot, you don't have to worry about the cluster nodes and what the CPU memory of each node requires. And since you no longer need to worry about the nodes, there's no need to guess how many nodes you're going to need to run your workload. So with that, you should no longer have to guess how big your cluster nodes are. So with GKE Autopilot, all you need to worry about is having a bit more discipline in detailing the workloads that will run in your Kubernetes cluster. This means it's very important that your Kubernetes resources YAML file have the accurate figure for how much virtual CPU and memory each container will require. You can also take advantage of Kubernetes applications. So there's open source applications, there's Google built, and there's also pay for containerized solutions with pre-built deployment templates. And that allows you to integrate the portability, simplified licensing, and group billing. So take advantage of some of these applications that are already built. pod clustering and auto-scaling, so we can scale horizontally or vertically. Horizontally means adding more resources, while vertically means adding more horsepower to your existing resources. You can set up a horizontal pod auto-scaling based on CPU utilization or some other custom metric of your choice. Cluster auto-scaling works on a per-node pool basis. Vertical pod auto-scaling will continuously analyze the CPU and memory usage of the pods and dynamically adjust the CPU and memory requests in response. And workload and network security. So GKE has a sandbox, and that'll provide a second layer of defense between your containerized applications or workloads for enhanced workload security. So GKE clusters natively by default support Kubernetes network policy to restrict traffic with pod-level firewall rules. Private clusters in GKE can be restricted to a private endpoint or a public endpoint that can only be reached by certain IP addresses. Some more GKE features. So when you run a GKE cluster, you can incorporate a lot of the advantages that Google Cloud already brings, such as Compute Engine instances load balancing, node pools to assign node subsets, and that'll give you additional flexibility, automatic cluster node instance count scaling, automatic cluster node software upgrades, automatic node repair, and Google Cloud Operations Suite logging and monitoring. So you can see there's a lot of automatic stuff going on here, right? And the more automatic, the less that you have to manage on your own. Some advantages of GKE. So Google Kubernetes Engine offers you a chance to single-click clusters with up to 15,000 nodes, so you can start very quickly. You can leverage high availability control plane, and that means you can incorporate multi-zone and regional clusters, four-way auto-scaling and release channels. It's highly secure by default. That includes vulnerability scanning of container images and data encryption, and integrated cloud monitoring. So you can look at your infrastructure, you can look at your application, and you can dial into just Kubernetes-specific views. Some more advantages of Google Kubernetes Engine. It offers you secure, rapid application development. So you can develop a wide variety of applications with support for stateful, serverless, and application accelerators. It's more efficient operations with release channels. So choose a channel that fits your business needs. It could be rapid, regular, stable. These are 3 types of release channels. And they have different cadences of node upgrades and offer support levels aligned with the channel nature. And infrastructure management with Google Site Reliability Engineers. So you don't have to focus on the hardware and the site. You can just focus on your application and let the site reliability engineers monitor your cluster and all the resources that it's using. Now let's discuss Google Kubernetes Engine's modes of operation. So in addition to the benefits of the fully managed control plane and node automations, GKE offers 2 modes of operation. You have standard operation, where you control all the underlying resources, and autopilot, where all the underlying resources like scaling and monitoring and health checking is all done for you. Hence the name autopilot. So it really comes down to, do you want to manage your own underlying resources, or do you want to let Google take care of it? That answer will determine which mode of operation that you use. GKE Standard Mode. So Standard Mode provides a lot of functionality, such as policy hardening, container layers, and auto-scaling. Standard GKE offers capabilities only to manage the control plane. All other features such as nodes or node pools, automation, and security has to be managed manually by the user. You manage the cluster's underlying infrastructure, and that gives you flexible node configuration. GKE standard mode features. So, in standard mode, you get full control of the cluster and the node management. So you manage all that underlying infrastructure. That does give you flexible node configuration, and you can have admin assigned configurations, because again, while you have all that control over the underlying nodes and hardware, you can incorporate these admin assigned configurations and you get a bit more flexibility. Your clusters are using a pay per node usage for billing. GKE Autopilot mode is an operation mode in Google Kubernetes Engine which extends the Kubernetes cluster configuration and management capabilities. So with GKE Autopilot, users can manage the entire Kubernetes infrastructure, providing just the application configuration. This will give you a much lower cost of cluster management. The operation mode takes care of the resources, the node provisioning, any security configuration, and auto-scaling and upgrades, all equaling much more improved cluster optimization. Autopilot also adds and automates much needed operational, security, and provisioning features that standard GKE lacks. This will lead to reduced costs and management time, which leads to improved workloads. Some advantages of Google Kubernetes Engine Autopilot. There's no need to monitor health. It's done for you, and any scaling is done based on that health monitorization, and it's all automatic. There's no requirement to calculate a workload capacity. So all that amount of the compute capacity that a lot of times people need to calculate beforehand is not necessary in this case because the scaling can handle it for you. And it supports Kubernetes APIs and tools. So you can use the Kubernetes APIs and all the tools in its rich ecosystem. Some more GKE Autopilot features. So when compared with the standard GKE mode, where users manually provision their resources based on the requirements, GKE Autopilot drastically reduces the decisions required to provide a secure, production-grade infrastructure. Very few steps are required from a developer's perspective. In fact, you always stay within the GKE environment without having to interact with the Compute Engine APIs or CLIs, so these nodes are not accessible now in Autopilot like they were in standard mode. So you won't see these engines in the Compute Engine console. They're not there. You can't manage them. The service automatically determines the best configuration based on the workloads, and that'll free up your dev team to focus more on the applications. As a result, now you're only paying for the CPU, the memory, and storage that your pods request while they're running. So it's a pay as you go, and you're only paying for what you use. Autopilot clusters are pre-configured with an optimized cluster configuration that is production ready. This streamlined configuration follows GKE best practices and recommendations for cluster and workload setup and security. Some of these built-in settings can't be changed, while other optional settings can be. Autopilot configuration modes. So with Autopilot, Google Kubernetes Engine manages a lot of the complexities in the lifecycle of your cluster. So if your cluster is pre-configured, that means that this setting is built in and you cannot change it. If it's default, this setting is turned on, but you can override it. And optional means the setting is turned off, but you can go ahead and turn it back on. Now let's look at Google Kubernetes Engine cluster configuration. So this table illustrates the two types of clusters, the standard cluster and the autopilot cluster. So autopilot is a fully provisioned and managed cluster configuration. And for clusters created using the autopilot mode, the cluster configuration options are managed and made for you. Autopilot clusters are pre-configured with the optimized cluster configuration, and it's ready for production workloads. So let's take a look at the differences between a standard cluster configuration and an autopilot cluster configuration. The availability type for a standard configuration is regional or zonal, while autopilot is regional only. The Kubernetes features in standard are production or alpha, whereas autopilot only offers the production features. Network isolation can be private or public for both standard and autopilot, whereas network routing is a little different. So standard, you can choose between a VPC native or routes-based, whereas autopilot is just VPC native only. And the version for standard cluster configurations are release channel, default, or specific. So release channels are like regular, rapid, and stable, and they're to use for your development and your deployment needs. You can also use the default or specific versions, whereas autopilot, you just get the release channel. Cluster availability types. So we have two availability types when we create a cluster. And this is really tailored to the availability requirements of your workload and your budget that you're willing to spend. So the types of available clusters are zonal clusters and regional clusters. So zonal clusters can be single zone or multi-zonal, whereas regional clusters exist at a regional level. Zonal clusters. So zonal clusters exist in a single zone or a multi-zonal arrangement. So single zone clusters has a single control panel running in one zone, and that control panel manages workloads on nodes running in the same zone. Whereas multi-zonal clusters has a single replica of the control plane running in a single zone and has nodes running in multiple zones. During an upgrade of the cluster or an outage of the zone where the control plane runs, workloads will still run. But the cluster and the nodes and the workloads can't be configured until that control plane is back up and available. Multi-zonal clusters give you that high availability because you can run your workloads over multiple zones. And if one zone goes down, you can still continue to run your workloads. Regional clusters. So regional clusters have multiple replicas of the control plane running in multiple zones within a given region. Nodes run in zones with a replica of the control plane. Because a regional cluster replicates that control plane in nodes, it will consume more compute engine resources than a single zone or a multi-zonal cluster. Cluster versions. So when you create a cluster, you can choose the cluster-specific Kubernetes version, or you can make choices about its overall mix of stability and features. Clusters created in the autopilot mode, remember, are pre-configured to only use release channels. So what is a release channel? So if you know the level of stability you need for a given cluster, you can enroll that cluster into a release channel. So new clusters are enrolled in the regular release channel by default. The three release channels are rapid, regular, and stable. And that gives the users the choice of utilizing the newest or the most stable Kubernetes releases. We have a default version, so if we don't use a release channel or choose a cluster version, the current default version is used. The default version is selected based on usage and real-world performance and is changed quite regularly. You also have an option to use a specific version, so if you know the specific supported version of Kubernetes will work for your workload, then you can specify it when you create your cluster. So how do we bring all the clusters together and allow them to speak? Right? How do we implement cluster networking? When we create that GKE cluster, we can specify the network routing mode and how to isolate our cluster network. So we can use VPC native and route-based clusters. So in the Kubernetes engine, clusters can be notable according to the way they route traffic from one pod to another pod. Whether that's in a same region or multi-zonal approach, a cluster will use an alias IP. Anytime a cluster uses an alias IP, it's called a VPC native cluster. A cluster that uses Google Cloud routes is called a route-based cluster. VPC native is the recommended network mode for new clusters. You also have to look at network isolation. So we can configure public access to our workloads, but we have to go and create those routes because the routes aren't created automatically. Private clusters assign internal addresses to pods and nodes and workloads, and they completely isolate them from the public networks. Kubernetes features and clusters. Kubernetes features follow a defined lifecycle. First as an idea by an interested developer, maybe then sketched into some online discussions, and from there, it usually turns into code. The lifecycle I mentioned runs as alpha, beta, and stable. New features in Kubernetes are listed as alpha, beta, or stable, depending upon their status in development. In most cases, Kubernetes features that are listed as beta or stable are included with GKE clusters. Kubernetes alpha features are available in special GKE alpha clusters. So an alpha cluster has all Kubernetes alpha APIs enabled. You can use alpha clusters for early testing and trying out and validating some of the new Kubernetes features. They are not supported for production workloads. They cannot be upgraded, and they will expire within 30 days. Stable, on the other hand, will deliver slightly older and more stable versions than in the past. And beta is somewhere in between. Right, so a new feature is in alpha mode. You work out the kinks, test it out, move it into beta mode, and once it's completely ready, they'll move it into the stable part of the life cycle. And from there, you can use it right in your main production GKE clusters. In this video, I'm going to show you how to create the two different types of clusters in Google Kubernetes Engine. So you'll see I'm in the Google Cloud Platform, and I'm in the dashboard for my web app. So if I come up to the search bar, and I type in GKE, you'll see the first page is the Kubernetes Engine. So let's go ahead and click the Kubernetes Engine, and that brings us into the Google Kubernetes Engine console. So from here, I have my options to create two different types of clusters. So I'm going to come down and I'm going to click Create underneath the Kubernetes clusters. Once I click Create, I'm given two options here. I have a standard cluster and an autopilot cluster. So I'm going to go ahead and click Compare just so I can view both of the cluster types and see what features are available with both. So you have your autopilot mode and you have your standard mode. So with autopilot, you'll see most of it is managed for you. So scaling is automatic. The nodes are managed by Google. Right? Your configuration is already streamlined for you. Most of the workloads are accepted. You pay per pod. And you get a Kubernetes API and node availability service level agreement. With standard mode, you configure the scaling. You manage and configure your nodes. You configure all the options. It's completely unmanaged. So in this case, I'm going to configure a standard mode Kubernetes. Then I'm going to go ahead and configure an autopilot mode Kubernetes, just so we can look at how much configuration that we have to do for each. I'm not going to actually deploy the cluster. That'll come later. But it's good to look through all of our options to see the difference when setting up a standard mode cluster versus an autopilot mode cluster. So go ahead and click Configure on the standard mode. That brings us into the console to create a cluster. And you'll see right now that it is unmanaged. We do a lot of the configuration here. So we specify a name, in this case cluster 1. A location type, so is it going to be a zonal cluster? Or is it going to be a regional cluster? And if it is a zonal cluster, is it going to be multi-zonal? Okay, so I'm going to leave it as zonal. The zone is in US Central 1C. I can specify default node locations. So if I go ahead now and click US Central 1A, you'll notice that I'm deploying it into two zones, and this is multi-zonal. My control plane zone is in US Central 1C, and I have nodes deployed in US Central 1A as well. So if I come down to control plane version, you'll see the two different versions. I have a static version. So if I choose static version allows me to specify the exact version of Google Kubernetes Engine that I want to use. So if I click the drop down, you'll see all the different versions here. So if you have a workload that needs a specific version, then static is for you. If I click release channel and I click the drop down, you'll see three. You got a rapid channel, a regular channel, and a stable channel. So your regular channel is your default channel with all the regular features that have been tested and gone through all the stages. Stable channel is a lot more of the older features that are a lot more stable. And with the rapid channel, you can try out some new features that you wouldn't with the regular channel. So I'm going to leave it at regular channel. Now, if I wanted to create this cluster right now, I can just click create. I can also view the equivalent REST or command line commands. So go ahead and click command line, and you'll see a big command here. This would create your cluster in the command line. I can go ahead and click it right now in the Cloud Shell if I wish. I'm going to click close, and I'm going to come down and click cancel. Now I want to look at autopilot. So under Kubernetes clusters, let's click create. And under autopilot, let's click configure. Now you'll see things are not as detailed, right? Nodes are automatically provisioned. The networking is taken care of. The security and telemetry is all taken care of by Google. You just give it a name, give it a region, then set your networking parameters. So should this be a public cluster? Should this be reachable from the internet? Or should this be a private cluster? We can expand networking options. We can see our default network, our node, the pod address range, and the service address range. We can leave that all to default. We don't really need to change that unless we really have specific IP CIDR block requirements. And we can click Advanced option, and you'll see that we have a release channel now. Just the rapid channel or the regular channel. There's no stable channel in the autopilot cluster. We can enable a maintenance window. So anytime Google makes any changes to our cluster, it would be in that maintenance window. So I'm going to go ahead and click cancel. I'm not going to actually create it now. But I hope this video showed you the two different types of clusters, autopilot and standard, and what you need to configure for each one and the differences of each one and how one is completely managed by you while another is completely managed by Google. Now let's look at Kubernetes pods. So what is a pod? Pods are the most basic deployable objects in Kubernetes. A pod represents a single instance of a running process in your cluster. Pods can contain one or more containers. These containers can be Docker containers, for instance. And when a pod runs multiple containers, the containers are managed as a single entity and share the pod's resources. Generally, running multiple containers in a single pod is an advanced use case. Some Kubernetes pod features. So a pod is meant to run a single instance of your application on your cluster. But you should refrain from creating individual pods directly. Instead, you generally create a set of identical pods called replicas. These will be used to run your application. All these replicas, though, must be managed and created. This is done via the controller. Pods can also perform horizontal scaling. So we know horizontal scaling is by scaling out, adding more resources, changing the number of pods in this case. A pod runs on nodes in your cluster. Once created, a pod remains on its node until the process is complete, the pod is deleted, the pod is evicted, or the node fails. If a node fails, pods on the node are automatically scheduled for deletion. What resources do Kubernetes pods require? Pods will require shared networking and storage resources for their containers. So from a networking point of view, pods are automatically assigned unique IP addresses. Pod containers share the same DNS namespace, IP addresses, and ports. Containers in a pod communicate with each other inside the pod on the local host. So for storage, if a pod requires a shared storage solution, we can create a set of shared storage volumes that we can share amongst all the containers in the pod. Let's look at the pod lifecycle. So pods are short-lived. They're not designed to run forever. And when a pod is terminated, it's gone forever. So in general, pods don't disappear. Right? They're usually deleted by a user or a controller. Pods also don't heal or repair themselves. So if a pod is scheduled on a node and that node fails, the pod is deleted. It's just that simple. Similarly, if a pod is evicted from a node for any reason, the pod doesn't replace itself. Each pod has a pod status API object, which is characterized by a pod status field. Pods will publish their status to the status phase field. The phase of a pod is a high-level look at the pod in its current state. So, what states and phases can they go through? First one is pending. The pod has been created and accepted by the cluster, but one or more of the containers aren't up and running yet. This phase includes time being spent on scheduling a pod on a node and downloading any images. Next, it goes into running. The pod is now bounded to a node. All the containers have been created, and at least one container is running or in the process of starting or restarting. Succeeded means all containers in the pods have terminated successfully. Terminated pods, remember, do not restart. Failed. So if you see a status of failed, all containers in the pods have terminated, and at least one container has terminated in failure. And that's the difference between failed and succeeded. Succeeded, they all terminated successfully, but with failed, at least one terminated in failure. And unknown. So the state of the pod can't be determined. That may have to do with some networking, any messages not being sent back and forth, and we don't really know what the state of the pod is in right now. Pod creation. Because pods are temporary, it's not necessary to create pods directly. And because of the fact that pods can't repair or heal themselves, it's recommended that you do not directly create pods yourself, but rather controllers are recommended to create and manage pods for you. Controllers can roll out updates, it can change an application version, and it really got a whole grip on the updating process for you, and it's managed, so you don't really have to worry about it. So don't manually create the pods. Let the controller do all the work for you to create and manage those pods. Pod requests. So when a pod starts running, it requests a minimum amount of CPU and memory. And this will help Kubernetes schedule the pod onto an appropriate node to run the workload. A pod will not be scheduled onto a node that doesn't have the resources to honor that pod's request. You can't schedule a pod that requires 2 gigabytes of memory on a small instance that only has a total of 1 gigabyte of memory. You can configure the CPU and memory requests for a pod based on the resources your application needs. It is strongly recommended that you configure requests for your pods based on the requirements of your actual workloads. So setting too small a value for CPU or memory could cause too many pods, or a suboptimal combination of pods to be scheduled on a given node. Scheduling too large a value for CPU or memory could cause the pod to be unschedulable and increase the cost of the cluster's resources. Pod limits. So by default, a pod has no limit on the maximum amount of CPU or memory that it can use on a node. But you should set limits to control the amount of CPU or memory your pod can use. In addition to setting a pod's limit, you can specify limits for individual containers as well. So if your pod is limited to 16 gigabytes of RAM, then you can set limits on the individual containers to consume that 16 gigabytes of RAM. You don't want one container using all the memory. So you can set these individual limits on containers as well. And it's strongly recommended that you configure limits for your pods. Pod templates. So controller objects such as deployments and stateful sets contain a pod template. A pod template is no more than a pod specification that determines how each pod should run. Controller objects use pod templates to create pods and make changes to them. And when a pod template is changed, it's only changed for future pods and is not applied to the existing pods. Determining pod nodes. So how do we control which node a pod runs on? By default, the pod runs on nodes in the default node pool for the cluster. But we can configure the node pool a pod selects either explicitly or implicitly. So explicitly means we can explicitly force a pod to deploy to a specific node, or implicitly, which means we can specify resource requests for the containers we run. And the pod will only run on nodes that satisfy those resource requests. So we're not explicitly stating it, we're kind of implicitly stating it, right? You can only run on the nodes that satisfy the resource requests. Pod usage. So pods can be used in two main ways. Pods that run in a single container. This is the simplest and most common pod pattern, is a single container per pod. But you can also get pods that run multiple containers that share resources. So these will be primarily used to support applications that are co-located or co-managed, and they need to share resources. In this video, I want to talk about deploying workloads in the Google Kubernetes engine. So to deploy and manage your containerized applications and other workloads in GKE, you use this Kubernetes system to create Kubernetes controller objects. These controller objects can be applications, daemons, and batch jobs running on your cluster. So Kubernetes provides different kinds of controller objects that correspond to different kinds of workloads that you can deploy and run in your Google Kubernetes environment. Some controller objects are better suited for specific types of workloads. So what types of workloads can we deploy in Google Kubernetes? We can deploy stateless applications. So stateless applications would be web servers like Nginx. It doesn't preserve the state, saves no data. Stateful applications, that requires its state to be saved, so we must incorporate some form of persistent storage. Batch jobs are finite, independent, and often parallel tasks which run to completion. This could be batch financial jobs at the end of the day, batch payroll, sending emails, and daemons. So daemons perform ongoing background tasks in their assigned nodes. And that keeps the user from having to intervene and do things, right? Because the daemons will do it on their behalf. Some daemons that you can run in Google Kubernetes are things like FluentD, which is an open source log analytics program, and multiple monitoring services. So let's take a look at them in the platform itself. So you'll see I have a cluster named cluster 2. I'm going to go ahead and click the name of my cluster, and then I'm brought into my cluster details. Over on the navigation menu on the left-hand side, under Clusters, choose Workloads. We can click Workloads. We have an option to deploy a containerized application or show the system workloads. Let's click Show System Workloads. So from here is where we can see the system workloads that are deployed on our behalf, and these things, kind of keep our Kubernetes cluster running. So you can see the name of the workload, its status, its type, the number of pods it's deployed to, its namespace, and the cluster. So you have Event Explorer for GKE. We can see its type is deployment and is deployed to one pod. We have FluentBit. So FluentBit is our unified logging agent. We can see that its status is okay. It's a daemon set and it's deployed to one pod. We have metrics agents and metrics agents for Windows. So you can see my GKE metrics agent is installed. It's a daemon set and it's installed on one pod. But you'll notice the GKE metrics agent for Windows has a warning, and it says daemon set has no nodes selected. This is because I have no Windows nodes, so I can't deploy that workload because it's a Windows-based workload. kubedns, kubedns autoscaler, these are all deployed out to my cluster. kubeproxy is not in use, so again, it doesn't have a daemon set with a node selected. We can scroll down a little further. We can see metrics server. It's installed. The NVIDIA GPU device plugin is not, because we don't have a GPU OS. We're not actually adding additional GPUs to our instances in the cluster. So if I want to now deploy another workload, say a container image, I can just come up to Workloads, click Deploy, use an existing container image of Nginx, come all the way down, click Continue, leave all the default values. The application name is Nginx, the default namespace. The app is called Nginx, so we'll put a label in with the key of app and a value of Nginx-1. Our cluster is pre-selected, so I'm going to go ahead and click Deploy. So this container image is now just deploying another workload to our cluster. This workload is our application, and it's a deployment, but nonetheless, we'll still see that Nginx workload under the workloads with all the other system workloads that we deployed. So now that it's finished, you can see it has been deployed. Come back up and go back out to our workloads. Click Refresh. Now you'll see is system object is a filter, and it's set to false. So let's click the X. Now we can see all of our workloads again. So we have all the system workloads, and you know there's system workloads because under namespace, it says kube system. But if we go down to our Nginx, that's in the default system. So that default namespace tells me that I deployed it, and it was deployed out to 3 of 3 pods. So I hope this video showed you the different types of workloads that are running behind the scenes in your Kubernetes cluster, and how to deploy another workload in the way of an Nginx web server to your cluster environment. Let's discuss authentication in the Google Kubernetes engine. So there are two concepts of an identity in Kubernetes. We have user accounts. These accounts represent user personas and are global and unique across all namespaces. User accounts are not managed by Kubernetes and can only be referred to inside the cluster. So that means there's no possibility to create or delete them, and you can only grant or revoke their access to cluster resources. User accounts are typically created by a company's identity provider. And we have service accounts. These are special types of accounts that are meant to represent the applications running inside the pods. Service accounts are namespace, meaning each account must necessarily belong to a certain namespace, and they can have the same name as long as they're created in distinct namespaces. Service accounts are actual Kubernetes objects that are managed by the cluster, and they can be created and used as an identity for the pods running your application if it ever needs to interact with an API server. Every namespace comes with a default service account created automatically when you create the new namespace. After, when you deploy a pod, the credentials of the default service account of the namespace will be mounted as a volume in the pod file system unless you create a new service account and explicitly indicate that you want to use that as the identity for your pod. Control plane security. So in GKE, the Kubernetes control plane components are managed and maintained by Google. The control plane components host the software that runs the Kubernetes control plane, including the API server, scheduler, controller manager, and the etcd database where your Kubernetes configuration is stored. By default, the control plane components use a public IP address. You can protect the Kubernetes API server by using authorized networks and private clusters. You can handle cluster authentication in Google Kubernetes Engine by using Identity and Access Management as the identity provider. Another way to secure your control plane is to ensure that you're doing credential rotation on a regular and frequent basis. When credential rotation is initiated, the SSL certificates and cluster certificate authority are rotated. This process is automated by GKE and also ensures that your control plane IP address rotates. Node security. So GKE deploys your workloads on Compute Engine instances running in your Google Cloud project. These instances are attached to your GKE cluster as nodes, and they offer some form of node security. By default, GKE nodes use Google's container-optimized operating systems as the operating system to run Kubernetes and its components. These operating systems have some enhanced security features like lockdown firewall, read-only file system, and limited user accounts and a disabled root login. Node upgrades should be performed. You should patch your operating system on a regular basis. There will be security issues and vulnerabilities, so upgrading and patching is necessary. You'll want to protect your nodes from untrusted sources. So for clusters that run unknown or untrusted workloads, it's a good practice to protect the operating system on the node from an untrusted workload running in a pod. So some multi-tenant clusters, such as software as a service providers, often execute unknown code submitted by their users. So you want to enable a GKE sandbox on your cluster to isolate untrusted workloads in sandboxes on your node. And finally, you want to secure your instance metadata. So since these GKE nodes run as Compute Engine instances, they have access to instance metadata by default. This metadata is used to provide nodes with credentials and configurations used in bootstrapping and connecting to the control plane. As a result, a pod running on a node doesn't necessarily need this information, but now contains sensitive data, and it has access to that sensitive data. You can lock down sensitive instance metadata paths by disabling legacy APIs and using metadata concealment. In the area of network security, you have two real things you want to focus on. You want to limit pod-to-pod communication. So by default, all pods in a cluster can be reached over the network via their pod IP address. Also, all outbound traffic is allowed to any address accessible in the VPC. Cluster administrators may choose to lock down the ingress and egress connections created to and from the pods in a namespace by using network policies. You may also want to filter load balance traffic. So to load balance your Kubernetes pods with a network load balancer, you need to create a service of type load balancer that matches your pod's labels. Once your service is created, you'll have an external facing IP that'll map to ports on your Kubernetes pods. This can also be achieved using an internal load balancer as well, because the internal load balancer also respects the load balancer source ranges when it's necessary to filter out traffic from inside of the VPC. Securing our workloads. So Kubernetes allows users to quickly provision, scale, and update their container-based workloads. But we need to secure our workloads. We don't want everyone to be able to go in and look at the workloads. We don't want to have containers running and affecting other containers in the same cluster. So one of the first things we need to do is limit the pod container process privileges. So limiting the privileges of containerized processes is important for the overall security of your cluster. You can do things like change security settings of user groups, available Linux capabilities, the ability to escalate privileges. You also want to assign access to Google Cloud resources. From time to time, your pods and containers might need to access other resources in the Google Cloud. So we can do this by using a workload identity. It's the simplest and most secure way to authorize pods to access Google Cloud resources. We can also use a node service account or a service account JSON key. One final thing is that it is very important to implement binary authorization. So binary authorization is a service on Google Cloud that provides software supply chain security for applications that run in the cloud. Binary authorization works with images that you deploy from the container registry. And with binary authorization, you can ensure that internal processes that safeguard the quality and integrity of your software have successfully completed before the application is deployed to your production environment. And finally, audit logging. So audit logging provides a way for administrators to retain, query, and process, and even alert on events that occur in your Google Kubernetes Engine environments. Administrators can use the log information to do analysis, alerting, and reporting on how a fleet of GKE clusters are being used and by whom. So by default, GKE logs admin activity logs. You can optionally also log data access events, and you can also optionally log data access events. So who's accessing what data? Now let's discuss Google Kubernetes Engine networking. So Google Kubernetes networking allows you to control how your applications are deployed, how applications will communicate with each other, and how clients interact with your applications. So when you use Kubernetes to deploy your applications, it's important to change how you think about network design. With Kubernetes, you have to think about pods, services, and external clients, and how they communicate to each other, rather than thinking along the lines of hosts and VMs. So networking inside the cluster. Kubernetes uses various IP ranges. So when it comes to IP allocation, each node has an IP address assigned from the cluster's virtual private cloud. Each node has a pool of IP addresses that GKE assigns pods running on that node. This is by default a /24 CIDR block. Each pod has a single IP address assigned from the pod CIDR range, and each service has an IP address called the cluster IP. This is assigned from the cluster's VPC network, and you can optionally customize the VPC network when you create the cluster. Pods. So in Kubernetes, a pod is the most basic deployable unit. A pod will run one or more containers. 0 or more pods run on a node. So each node in the cluster is part of a node pool. These nodes are virtual machines, and each are running as an instance in the compute engine. When Kubernetes schedules a pod to run on a node, it creates a network namespace for the pod in the kernel. This network namespace connects to the actual physical network interface that the pod is using, so the packets can flow to and from the pod itself. Kubernetes will also assign an IP address, so that's the pod IP, to the virtual network interface in the pod's network namespace. By default, each pod has unfiltered access to all other pods running on the node of the cluster. Services. So in Kubernetes, we can create key value pairs called labels to any Kubernetes resource. These labels are then used to group multiple related pods into a logical unit called a service. That service is given a stable IP address and ports, and then does load balancing amongst the set of pods whose labels match the labels that we defined earlier in the label selector. So Kubernetes manages connectivity amongst pods and services using the kubeproxy component. This is deployed as a static pod on each node by default, and any GKE cluster running 1.16 or later will have the kubeproxy daemon set. Networking outside the cluster. So GKE provides 3 different types of load balancers to control the access to and spread the load across your cluster as evenly as you can possibly get it. You can configure one service to use multiple types of load balancers at the same time. So we have external load balancers. They will handle the traffic from outside the cluster and outside of your VPC. So this would be for client connections coming from the internet. We also have internal load balancers. That'll manage traffic coming from within your VPC network. So internal workloads, and when the application speaks to each other, it'll take advantage of internal load balancers. And HTTP or HTTPS load balancers. These are load balancers used for exclusively HTTP and HTTPS traffic. They use an ingress resource rather than a forwarding rule to route traffic to a specific Kubernetes node. Connectivity between nodes. So you need to limit connectivity between nodes from time to time. Choose your firewall rules carefully. So if you do the wrong rules, it may have bad effects. You don't want to allow traffic that you don't want to allow, but you also don't want to block legitimate traffic. Avoid rules that deny necessary services. For example, if you put on some egress deny rules to nodes in your cluster, you're going to break some functionality, especially with node port, for example. Limiting connectivity. So again, by default, all pods running in the same cluster can communicate freely together. However, you can limit that connectivity in 3 different ways. So you can limit access between pods. So if you don't want specific pods speaking to each other, you can limit that access, and you can limit it using a network policy. So network policy will allow you to restrict the ingress and egress of pods based on an arbitrary combination of labels, IP ranges, and port numbers. External load balancer. So if you're using a service and it has an external load balancer, any traffic from any external IP can access your service by default. You can restrict which IP address ranges can access your endpoints within your cluster, and you can specify multiple ranges and update the configuration of a running service at any time. You can also limit access using an HTTPS load balancer. So if your service is using an HTTP load balancer, you can use the Google Cloud Armor security policy to limit which external IP addresses can access your service and which responses to return when access is denied. So there's multiple ways to limit the connectivity and the network privileges in your Google Kubernetes Engine environment. Now let's discuss storage for your applications that are running in the Google Kubernetes Engine. So there are numerous options for storage for your applications running in GKE. The choices vary in terms of flexibility and ease of use. Google Cloud offers several storage solutions that are specialized for your specific needs. And beyond these, Kubernetes provides storage abstractions which you can use to offer storage to your cluster. And it comes in 2 different types. They're called volumes and persistent volumes. And we will explain the difference between those 2 a little further down in this course. Manage storage options. So the simplest storage options are Google Cloud's managed store products. So if you need a database, consider Cloud SQL. Cloud Spanner is there and that's a fully managed, mission-critical relational database that offers transactional consistency at a global scale. Or if you need a schemaless database, you can use the data store option. Some more managed storage options. So where do we want to store our images? We have a bunch of Docker images. Where do we want to store them? We can store them in a container registry, or we can use the cloud storage for object storage to store our Docker images. Some more managed storage options. So you'll want to use a file store if your application requires a managed network attached storage. But what if your application requires block storage? Well, then you can use persistent disks. You can provision persistent disks manually, or Kubernetes can dynamically provision them for you. And that's what we call persistent volumes, and we're going to talk about that in the next section. And if you have POSIX compatible file storage, you can use a file server on the compute engine. Now, Kubernetes storage abstractions. Kubernetes storage abstractions provide file system and block-based storage to your pods. They're not used with managed databases or cloud storage. And we have two types. We have volumes. Volumes are storage unit accessible to containers in a pod. Some volume types are backed by ephemeral storage. So ephemeral storage is temporary storage. It don't persist after the pod ceases to exist. These types are useful for storing configuration information or scratch space for applications. Persistent volumes is a cluster-wide resource used to store data. The method used to store data is such that it continues beyond the lifetime of the pod. So on a worker node, the persistent volume doesn't get backed by locally attached storage, but it gets backed by network storage system like EBS, NFS, or a distributed file system. Persistent volumes run independently, which means data stored within persistent volumes will stick around even if the pods are deleted or recreated. Persistent volumes are provisioned by persistent volume claims, PVC, and it's a request for the platform when you want to create a PV. You can also attach PVs to your pods through a persistent volume claims. Pods use these persistent volume claims or PVCs as volumes. The cluster inspects the PVC to figure out the bound volume, and it also mounts the volume for the pod. So these are your ways that give you some storage abstraction and allow your pods to use some shared storage in the Google Cloud environment. In this video, I'm going to deploy a Google Kubernetes Engine cluster. So I'm in the dashboard for my web app, and I need to get to the GKE console. So I'm going to come up under Search Products and Resources, just type in GKE, and under Products and Pages, you'll see Kubernetes Engine. So let's go ahead and click the Kubernetes Engine and come into the Kubernetes Engine console. So here is where I can first create my cluster. I have to create that cluster before I can really deploy anything on it or create any workloads. So I'm going to come down and click Create, and I'm going to choose a standard cluster this time. I want a bit more flexibility. So I'm going to click Configure on the standard cluster, and here's where I kind of configure all the details about this cluster that I'm going to deploy. So I give it a name. I can leave it at cluster 1. I can change that name if I wish. I choose a location type, so zonal or regional. And if it's zonal, I can come down, specify the default node locations, and make it multi-zonal. For the purposes of this demonstration, I'm going to leave it just at zonal and in US Central 1C only. My control plane version, I'm going to leave it at a release channel. So really, with a release channel, you get automatic upgrades when the new versions are ready. But with a static version, you only get one version, and if there's any upgrades, you don't automatically upgrade. So we're going to go with a release channel. The release channel is a regular channel, and we're starting at version 1.19. Before I go ahead and click create, I want to make sure I configure my node pools. So if I click on default pool, you'll see the node pool details. So the new cluster will be created with at least one node pool, and it's pulling the details from here. So you'll see I have number of nodes as 3. I can enable auto scaling here as well, right? So really when you deploy the cluster, you're saying what version of Kubernetes, but you need to integrate the node pool details to tell Kubernetes what kind of nodes to spin up. Do we want to spin up auto scaling on these nodes, and how many of these nodes? So I'm going to click enable auto scaling. Minimum number of nodes being 3, maximum number of nodes being 6. I can specify my node locations if I wish. So that looks good. If I come over and click nodes, you'll see here's where I get to choose the type of nodes. So I'm going to go with a container optimized OS, E2, and their E2 medium. My boot disk is a standard persistent disk of 100 gigabytes. So this is your template for all the nodes that will be deployed within that cluster. Under security, I have my service account. So I'm just going to use the Compute Engine default service account. And under metadata, I can add Kubernetes labels or any node taints. Under cluster, you'll see more settings. So automation, networking. So we can choose our network. If we had multiple, I only have one, so I'm going to leave it on default. More cluster security. So do we want to enable shielded GKE nodes or confidential GKE nodes? Do we want to enable application layer secrets or workload identity? So you can find all your cluster security here, your metadata, and your features. Right? So we can enable Cloud Run for Anthos if we're using a serverless workload. We can enable Cloud TPU, usage metering. So really, we're deploying a cluster, and all of our cluster settings are here, and the nodes that we deploy on that cluster, they're all found here. So I'm going to go ahead and click create, and you can see after some time the cluster is finished, has the green check marks. We have number of nodes of 3, total virtual CPUs is 6, and total memory is 12 gigs. So if I click this cluster by its name, I'm brought into all the details. So I can see the name, the location type, the channels, everything we set earlier, I can see it here. If I click nodes, you'll see that under nodes, I'm spinning up 3 VM instances, which are viewable from the Compute Engine page as well. I can add more node pools. I can deploy. I can connect to the clusters. I can even come down under the cluster and add more storage and check out the storage classes that I'm using. So I'm going to come back over to my navigation menu. I'm going to come back into Home and Dashboard, and I want to look at the Compute Engine. So once you're on the dashboard for your project, click Go to Compute Engine. Now you should see those nodes spinning up, and you should see 3 VM instances that represent your cluster. So you can see I have GKE Cluster 1, Default Pool, Cluster 1, Cluster 1. So these are the 3 VM instances with my Google Kubernetes Engine cluster. I also have another cluster running that you can see it's identified by GKE Cluster 2. So I hope this video showed you how to go in, create a cluster, specify your node templates and your node configurations, and deploy a cluster in the Google Kubernetes Engine in the Google Cloud Platform. In this video, I'm going to demonstrate how to deploy a container image to your Google Kubernetes Engine cluster. So I'm in the Kubernetes Engine console. You'll see I have an autopilot cluster running. It's in US Central 1. So I want to deploy a container image to this cluster. So I'm going to come right up on top of the title bar, and I'm going to go ahead and click Deploy. Now it asks me for a container. So do I want an existing container image, or do I want a new container image? you'll notice that it says under image path, enter your image path or choose from Google Container Registry. You can also try to deploy with the official Nginx image, and then it says Nginx:\latest. And that's what they put into the image path. If I didn't want to use Nginx and I wanted to use a new container image, I could click New Container Image. And if I do use one of the cloud source repositories, or GitHub, or Bitbucket, I need to make sure I have the cloud source repositories API and the cloud build API enabled. Then I would specify my repository, the Docker file path, and the image name. I'm going to go back to existing container image. I'm going to use Nginx:\latest, and that's the official Nginx image. Any environment variables I can add here. I'm going to leave that empty, and I'm going to come down and click Continue. So here's the configuration. I have to give the application a name. It names it automatically by the container name, and then they append it with a -1. So it's Nginx-1 as my application name, and my namespace is going to be default. Under labels, we're adding a key value of app with the value of Nginx-1. If I want to view my YAML, I can come under Configuration YAML and click View YAML, and you'll see the YAML file that is going to declare the resources that we're deploying. I can save this as a text file .yaml if I want. I'm going to go ahead and click Close. I come down, I choose my cluster. So any of my clusters that I had would be under the drop-down menu. I only have one, so it took my autopilot cluster -1. I also have an opportunity here to create a new cluster. I'm going to leave it on autopilot cluster 1, and I'm going to come down and click Deploy. So you'll see it's using an existing cluster. Now it begins to create the deployment and wait for the pods. So this shouldn't take too long because, again, we're using an existing cluster. If we had to spin up a new cluster at the same time, it would take a little bit longer. Now when it's complete, you'll see an overview. You'll see the Nginx with the green check mark, and it appears that everything is up and fine. We can click Details, and we get a bit more details, the cluster, the namespace, how many replicas. So you'll see there's 3 updated, 3 ready, 3 available. Revision history will give us any revisions of the image. Events will show us any events. So it's scaled up the replica to 3. Any scaling events will be here. Any logs, and the YAML file itself. So I'll come back to Overview, and you'll see it says to let others access your deployment, expose it to create a service. So I'm going to go ahead and click Expose. You'll see that the port is 80. My target port should also be 80, but I can change that if I want to map, say, port 8080 to port 80. I can do that here as well. It creates a load balancer service type with a service name of Nginx-1-service. So if I click Expose, it creates a new service. I used an autopilot cluster, so I don't have access to those EC2 instances, so I can't get to those external IPs. But by creating this service and enabling port 80, the load balancer now will port map to our containers that are running in our autopilot cluster. So it's creating the service, then we're waiting for the load balancer with an external IP. Now when it's complete, if I come down into my details, you'll see external endpoints. I can go ahead and click this external endpoint, and it brings you right into the Nginx page. So now we have deployed Nginx containers on an autopilot cluster, and it's being port mapped using a load balancer service. So I hope this video showed you how to deploy Nginx in containers on the Google Kubernetes engine. In this video, I'm going to show you how to create a Google Cloud Service account and use the credentials in applications for Google Kubernetes engine. So I'm in the Kubernetes engine's console. And you'll see I have one cluster, cluster 2. So cluster 2 is running an application that needs to be able to view objects in storage. So right now, that is a problem because an application running on GKE must authenticate to use Google services such as Google Cloud Storage. And that's exactly what we want to accomplish. So how can we authenticate that? We want to assign a service account to a pod so we can isolate permissions for different pods. And that is done with the workload identity feature. So workload identity is a recommended way to access Google Cloud services from within Google Kubernetes engine. So GKE workload identity allows us to attach the service account to the Kubernetes pod and remove the hassle to manage the service account credentials JSON file within the pod or the cluster. So we're going to do this in the Cloud Shell. So I'm going to come up to my title bar and click Activate Cloud Shell. You'll see I'm establishing a connection to the terminal window, and now I have a Cloud Shell terminal window that I can run my commands on. So the first thing we should really do is create a new Google Service account. So I'm going to create a Google Service account, and it's called Workload Identity Demo Test. So I'm running gcloud IAM service-accounts create Workload Identity Demo Test. I hit enter. I've now created the service account. Now I need to actually add permissions to that service account. So I'm going to run a command, gcloud projects, add IAM policy binding with my project ID. Then I give it a service account of workload identity demo test at mywebapp-314016, and I'm giving it the role of storage object viewer, because applications will need to be able to view objects from time to time. So I'm going to go ahead and I'm going to add that role to the service account. If I scroll up, you can see that it updated the IAM policy and all the members that it updated that binding to. So I scroll back down, and now at this point, I know I have a cluster set up. So I want to make sure I get the credentials for that cluster and bring in those credentials so I can use kubectl. So I'm going to run a command, a gcloud container clusters, get credentials, cluster 2, and specify my zone. It fetches the cluster endpoint and the authentication data, and the kubeconfig entry is generated for the cluster. Now for an optional step, we can create another Kubernetes namespace. So I'm going to go ahead and I'm going to create a namespace called demo test. So I just type in kubectl, create namespace demo test, and you can see that the demo test namespace is now created. So really that's only optional, but it allows us to get away from the default namespace. Next thing we need to do is to create a Kubernetes service account. So previously we created a Google Cloud service account with the gcloud command. So I type in kubectl create service account. I'm using a namespace of demo test. So make sure you have your namespace correctly, and I'm giving it a name of workload identity demo test KSA. Then you can see the service account workload identity demo test KSA is created. So we've created a Google Cloud service account called workload identity demo test and a Kubernetes service account called workload identity demo test KSA. So the last thing that we need to do is bind that Google service account and the Kubernetes service account so that the Kubernetes service account can use the permissions granted to the Google service account. I paste in my code and I hit enter. At this point, it updated the IAM policy for the service account, and it's now bound to the demo test Kubernetes service account. So I hope this video showed you how to create a Kubernetes service account and using workload identity, link and bind that Kubernetes service account to a Google Cloud Service account to give your applications running on your Kubernetes clusters access to all the other Google Cloud resources that it needs. In this video, I'm going to show you monitoring and logging in the Google Kubernetes engine. So you'll see I have an autopilot cluster running. I can go ahead and click the name of the autopilot cluster, and it'll bring me into more details about this cluster. And from here, I can view my logs. So if I come up and click Logs, you can find your general cluster logs and your cluster's auto-scaling logs below. So everything about our cluster, from a log point of view, we can see here. So we'll see the Kubernetes API service requests. We can filter by severity. So we can filter emergency, alert, critical, error, warning, debug, info, and notice. So if we choose notice, we are going to get every notice. If we just choose emergency, we'll just get emergency and higher. So you'll see now you're getting a few warnings, failed to compute the desired number of replicas, right? So we had some issues a while back. And that's just our basic logging system where we can kind of see it within our cluster. But if I come up to the top right and click Operations, here's where we can view a lot more details about our cluster. So you'll see a link that says View in Cloud Monitoring. I'm going to go ahead and click View in Cloud Monitoring, and it brings me into the Cloud Monitoring console where I can view a little bit more information about my cluster. So you'll see the GKE dashboard, you'll see my clusters, and my namespaces. So right now, there are no alerts. There's nothing to see in my cluster, and there's no active alerts with my nodes. So they break it down via clusters, namespaces, nodes, and workloads, and Kubernetes services, and pods, and containers. So any alerts, you will see them here, and they break it down by individual service. If I want to look at Metrics Explorer, I can come over to the left and I can click Metrics Explorer. Here's where I have to find my resource type and my metric. So if I wanted to look at metrics for a GKE container, I can click GKE container, and then you'll see all the available metrics. So everything from accelerator memory total to CPU usage, to CPU utilization and disk capacity. From here, we can look at alerting. So if I choose alerting, I can create a policy alert so that if I have issues with my GKE cluster, I can be notified. And logs. So if I type in logs in the search bar, you'll see a logs dashboard. So go ahead and click logs dashboard, and now you'll see the GKE logs. So you'll see the GKE cluster logs by severity, GKE cluster errors, GKE container logs, and GKE container errors. So we can kind of pinpoint and look visually at this dashboard, and it kind of visually represents what's going on in the logs. So if I look at GKE container logs by severity, you'll see I have 765 that were in error, 943 that are in info, and 63 of warnings. So if I want to break this down even further, I can click errors, and you'll see the view logs come up. So if I click view logs, now it's pulling back a query with all the errors. You can see that it's a Kubernetes container, the severity is error, and the project ID is my web app 314016. It shows you your cluster names, your locations, and then on the right under query results, we can see all the errors. So if I choose one, for example, I can just click it. You see all the summary here about what actually failed and what went wrong. So I hope this video showed you through cloud monitoring and operations logging how to get an insight on your clusters, your nodes, your containers, and all the resources that you're running in Google Kubernetes Engine. So in this course, we've examined implementing Google Kubernetes Engine. We did this by exploring Google Kubernetes Engine benefits and key features, GKE modes of operation, main cluster types, and Kubernetes pods, creating GKE clusters and Kubernetes controller objects, GKE security features and networking. We also looked at storage options for GKE, deploying GKE clusters and containerized applications, and authenticating to Google Cloud and monitoring and logging. In our next course, we'll look at managing the Google Kubernetes Engine. In this video, I'm going to show you the different Google Kubernetes Engine dashboards that you can use to get insights on everything from your clusters to your workloads and even your services that are running in GKE. So right now I'm in the main dashboard on my Google Cloud platform. I'm going to come up under Search Products and Resources, and I'm going to type in GKE. And under Products and Pages, I'm going to click the Kubernetes Engine. So right now you're brought into your Kubernetes clusters dashboard. So there are a few dashboards available in the Kubernetes Engine. So over on the left-hand side, you'll see clusters. So we have a dashboard for clusters. You'll see that it displays the clusters in our current project, its location, the number of nodes, and the total virtual CPUs and total memory that these nodes are using. If you come over and click Workloads, then you have to click Show System Workloads. And here's where it displays workloads that are deployed to clusters in our project. So you can see the name, its status, its type. So is it a deployment? Is it a stateful set? Is it a daemon set? Is it a job? And then you see pod information. So how many pods is it deployed to in my cluster? You see the namespace that it's deployed to and the cluster that it belongs to. So if we scroll down, we can see all these different workloads. Right? We have NVIDIA GPU device workload. And I can look at this dashboard and see that the daemon set has no nodes selected. That's because we're not using a GPU added device. Kube proxy, Kube DNS autoscaler. Right, you can see these all belong to the Kube system namespace, and these are system workloads. Next, we have services. So if I click Services and Ingress, and if we click Show System Objects, this displays our project service and ingress resources. So it displays each name, the status, the type, so is it a node port or a cluster IP, the number of pods it's deployed to, and the number of pods it should be deployed to, so 1 of 1, 2 of 2, its namespace, and its clusters. So you can see I have a default HTTP backend, I have Kube DNS running, Kubernetes are running, and the metric server is running. So you'll notice that default HTTP backend is a node port, whereas the rest are cluster IPs. I can also come up and click Ingress. So Ingress are collections of rules for routing external HTTP traffic. So right now I'm not running any external HTTP traffic, but if I was, I would be able to see it under Ingress. Under Configuration, we have a configuration dashboard. This displays our project secret and config map resources. So you'll see our default token is there of type secret and certificates, and that's of type config map. If I come over and click storage, that displays the persistent volume claims and storage classes that are associated with our cluster. So right now I have no persistent volume claims. If I come up and click storage classes, you'll see the storage classes for this cluster. So I have a premium RWO, a standard, and a standard RWO. You can see the provisioner, the type, and the cluster it belongs to. And finally, we have the object browser dashboard. So this lists all the objects running in every cluster in every given project. so you see all of them as a whole. And lastly, applications. So the applications dashboard would show you all the containers, all the services, and your configurations that are managed together. We don't have an application deployed right now, but this is where you would come to view all the collaborative information about that application. So I hope this video showed you how to go in, look at all the different GKE dashboards, and view them and just see the different types of information that's available for you so you can get that insight into what's actually running and happening in your Google Kubernetes engine. In this video, I'm going to demonstrate how to manage your clusters by creating, editing, and deleting them. So you'll see I'm in the clusters dashboard. I have one cluster running. Now I'm going to create a new one. So I'm going to come up to the main title bar and click Create. From here, it tells me, do I want to create a standard cluster or an autopilot cluster? I want to have a bit more node flexibility, so I'm going to choose Configure on the standard cluster. Now I'm brought into my cluster creation. So I have to give it a name of cluster 2. My location type, will it be zonal or will it be regional? And if it's zonal, which it will it be multi-zonal? So if I click Specify Default Locations, and I select US Central 1A and 1B, this is going to be a multi-zonal deployment. Now I choose my control plane. So if I need a specific version, I can choose static version. Otherwise, I'm going to leave it on the release channel, and it's going to be on the default release channel. Over on the left-hand side, under Default Pool, this is the pool that's going to be created by default when we create this cluster. So you have to give it a name, the number of nodes per zone. Okay, so I'm going to say 1 per zone because remember, I'm using 3 zones. So if I use 3 per zone, then the total is going to be 9. I'm going to use 1 per zone, which will give me 3 total nodes. Here's where I can enable auto scaling or specify node locations. Under nodes is where I choose my operating system, the machine type, the series. So I'm going to choose a machine type of E2 Micro, and my boot disk. Any networking settings can also be down here as well. Under security, I can leave this as basic. It just has the Compute Engine default service account. And metadata, any node metadata I can put in here as well. So I'm going to go ahead and click Create to create this cluster, and then we can come back and edit some of these other settings after. So I come down and click Create. It creates the cluster, and once it's finished, you'll see the green checkbox next to cluster 2. Now, as you can see, cluster 2 is created. So now if I want to edit my cluster, I can just click the cluster name. It brings me into the cluster, and I can view all the cluster settings. So I have the name, the location type, the release channel, everything we set up earlier is here. And from here, I can do a multitude of things. So I'm really editing my cluster right now. Anything that I want to edit, I can click the pencil next to. So if I wanted to change a default node zone, for example, I can click the pencil to edit the node zones. And then maybe I can take it out of US Central 1A. I click Save Changes, and now I'm only using 2 node zones. Under Automation, I can edit my maintenance window. Right? As you can see right now, I can't edit anything because it's currently editing the default node zones. So once that edit gets finished and completed, then I can carry on with editing things like maintenance windows, vertical pod scaling, whatever I really want to edit in this cluster. I can edit all the networking information. So the maximum pods per node, I can change CIDR blocks. Under security, I can enable binary authorization. I can enable workload identity. So there's a lot of different ways to edit your clusters themselves. So right now, as you can see, it's still editing. And once that edit is finished, I'll be able to make some more changes should I want to. Now you can see the cluster has updated successfully. I can also add a node pool to the cluster if I want. So I click Add Node Pool. I'm brought into the node pool settings, and from here I can add a new node pool and associate that with the cluster itself. I'm going to click Cancel. I'm going to come back, and from here I'm going to delete my cluster. So I come up and I click Delete. It will delete any data in host path and the empty dir storage pods and any running containers as well. So I click Delete to confirm. It submits my job and begins to delete the cluster. Once the cluster is deleted, all the nodes will be removed, and you'll no longer be able to access this cluster from the Kubernetes engine because it is gone and all the resources will be gone as well. So I hope this video showed you how to create a cluster, how to edit your cluster, and how to delete your cluster when you are finished with it. In this video, I'm going to show you how to use volumes with your deployment. So you can create a deployment of your pods, and each pod can contain one or more volumes. So I'm going to use a deployment manifest in the Cloud Shell, and I'm going to walk you through how to deploy the 3 pods, and each have a volume named empty dir or an empty directory. So I'm in my Google Cloud Platform, and I'm in the Kubernetes Engine console. I'm going to come right up to the top of the title bar, and I'm going to click Activate Cloud Shell. I'm going to run all my commands within this Cloud Shell. So really, the first thing we need to do is create a manifest file. So once I'm in my Cloud Shell, and we do a sudo nano, and I'm just going to call this volumes.yaml. So it brings me into the volumes.yaml page. I'm going to paste in my code and we can review it. So I'm going to look at my code. So I'll scroll up to the top of my code and we'll look. So the app version is apps v1. It's a deployment. And now you'll notice the metadata. So this metadata and the name that we gave it, volumes example deployment, just gives us some data on this deployment and what we did. So we know that we did a deployment of pods with volumes. If we come down, we see the app still says demo. We come down and now we'll see the template volume mounts. So in the template volume mounts, you'll notice that this specifies the volume named cache volume is mounted at the file path cache. So you see the mount path is cache and the label name is cache volume. So really, we're going to deploy this manifest file now that says create pods 3 replicas, and each should have a volume called cache volume mounted to the /cache path. So I hit Control S to save, Control X to exit. So the next thing we need to do is create a deployment from that manifest file. So I'm going to type in kubectl apply -f for force volumes.yaml. All right, go ahead and hit enter. You get a pop-up. It's requesting your credentials to make a API call. I click authorize. Now it's running through that deployment. Now you can see the deployment has been created. And if we want to verify the deployment is running and the volumes are on these pods, we can type in kubectl describe pods volumes example deployment. It brings back our full details about the pod and prints information about each of these 3 pods in the deployment. So if we scroll through and we come up and look, we have to see, here it is. Under volumes, you can see cache volume. The type is empty dir. So that's a temporary directory that shares a pod's lifetime. And it's mounted to /cache. So I hope this video showed you how to create your volumes when you create a pod deployment and how to attach those volumes to your pods. In this video, I'm going to demonstrate how to create a secret to store some of your sensitive data. So what sensitive data would you want to store? That could be passwords, that could be OAuth tokens, and SSH keys. while you store this sensitive data in secrets, it's much more secure than if it was in plain text, right? So using these secrets gives you control over how that sensitive data is going to be used. So you can create a secret using the command line or a YAML file. I'm going to use the command line. I'm going to come up to the top title bar and click Activate Cloud Shell. And I'm going to run my commands in the Cloud Shell. So I'm just going to make the Cloud Shell screen a little bigger and wait for it to provision. So now it's provisioned. It's time to create our secret. So I'm going to do a directory listing, and we're going to see two files. We're going to see username.txt and password.txt. So if I do a cat on username.txt, you'll see it's R Spencer, and a cat on password.txt, you'll see it's password1. So now we want to create a secret because these are in plain text. So I'm going to type in kubectl, create, secret, and now I have to pass in three parameters. The secret type, which could be generic. So that's mean you're creating a secret from a local file or directory. It could be Docker registry secret type. So it creates a Docker CFG secret for use within the Docker registry. Or you could have a secret type of TLS, and that creates a TLS secret from a public-private key pair. In our case, we're going to use generic. Now we have to give a secret name. So the name of the secret, I'm going to call it credentials. And now we have to fill in the last field, the data field. So for the data parameter, we just have to add the data that we're going to add to the secret. So it could be a path to a directory containing one or more configuration files, or it could be key value pairs. In our case, we're going to create secrets from files. And now we say from file, username.txt, and from file, password.txt. So this creates our secret. It's a generic secret called credentials, and we're using the files username.txt and password.txt. So I go ahead and hit enter. You see secret credentials have been created. So now if we want to ensure and verify that everything went fine, we could type in kubectl, get secret credentials, -o, and we want to output it to a YAML file. And it spits out our output. So our password.txt now, you can see that it's secret, it's encrypted, and username.txt is encrypted as well. So you can see password.txt is encrypted, and username.txt is encrypted as well. So now you can go about using these secrets. So you can use a secret in your workloads, and you can specify these secrets as environment variables that reference these secrets values. Or you can mount a volume containing the secret itself. So what we want to do is mount a secret in a volume. So now I want to create a YAML file that will mount a secret in a volume. So let's go ahead and say touch mount.yaml. Then let's go into sudo nano mount.yaml. And let's paste in this code. So it's API version 1. The kind is a pod. The name is my pod, and under spec, I'm launching containers my pod. The image is Redis, but look at the volume mounts. So the name is foo. The mount path is etc/foo, and it's read only. But if we look at the volumes, you'll see the name is foo, and the secret is the secret that we just created. So we called it credentials. So we'll update our secret name to credentials. We'll save it. We'll Control X. And now we have to actually run that deployment now. So if I go ahead and run kubectl apply-f mount.yaml, hit enter, my pod has been created. So now if we want to confirm and verify, I can just type in kubectl get pod, my pod-o, and YAML to get the pod's YAML. Now we can look through. We're getting the full YAML file of this pod. And if we scroll up right from the beginning, we can see its name is my pod. The volume mounts are etc/foo, and that has our secret credentials already on there. So I hope this video showed you not only how to create a secret, but how to use that secret and mount a volume with the secret on it when you deploy a pod to your Kubernetes cluster. In this video, I'm going to discuss and demonstrate how to set up the config connector. So the config connector is a Kubernetes add-on, and it allows you to manage your Google Cloud resources through Kubernetes. So you're not managing your Google Cloud resources and your Kubernetes resources in two different places. A lot of development teams work with a mix of systems, a mix of tools, and a mix of APIs to manage their infrastructure. That can be a little bit cumbersome from time to time. So with Config Connector, you can now configure your environments with Kubernetes, with the end goal being that you can manage your Google Cloud infrastructure the same way you manage your Kubernetes application. And it involves a reduction in complexity and cognitive load for your developers. So the first thing we need to do with the Config Connector is to open up our terminal. So let's come up and activate our Cloud Shell and get a terminal window open. So the first command we need to do is to make sure the config connector is enabled on our cluster. So I'm going to paste in my code and let's take a look at it. It says gcloud container clusters update Richard cluster. That's the name of my cluster. I specify its zone, and then I specify the update add-ons config connector equals enabled. So I go ahead and click enter. It updates my cluster and it adds the config connector add-on. You can see that it's all done. So config connector creates and manages your Google Cloud resources by authenticating with IAM. And it authenticates with a service account, and it uses the GKE workload identity to bind that IAM service account with Kubernetes service accounts. So we're going to create a new identity by creating an IAM service account, then giving that service account elevated permissions to our project. So the first thing I'm going to do is paste in gcloud IAM service accounts create config account 1. Now this could be anything. You could change it to 2. You can just leave it as create config account. So I'm going to say create config account, hit enter, and it created a service account called config account. The next thing we need to do now is to give that elevated permissions in our project. So if I type in gcloud projects, add IAM policy binding, the name of my project, so my web app -314016, and now the member being a service account that we just created, config account at my web app -314016. And I'm giving it the role of owner. So I hit enter, and now you can see that it's been given the role of owner. Now we need to create an IAM policy that binds the IAM service account and the predefined Kubernetes service account that the config connector runs. So I'm going to clear my screen so we can get a better look. And I'm going to paste in my code. And now let's look at it. So I'm saying gcloud IAM service accounts, add the IAM policy binding for the config account that I just created, give it the member of a service account, and it's the CNRM controller manager. And we're giving it a role of a workload identity user. So the first step was to create that config account. Then it was to give it the role of owner on the project. Now we bind that IAM service account with the predefined Kubernetes service account. So I hit enter. You can see it updated the IAM policy for service account config account, and it binded my workload identity user for Kubernetes. So the last thing we really need to do now is configure the config connector. So we're going to create a YAML file. So I'm going to say nano config connect.yaml. And now I'm going to paste in my configuration. So let's take a look at it. I say API version core.cnrm.cloud.google.com/v1 beta 1. The kind is a config connector. The metadata has a value of name of config-connector.core.cnrm.cloud.google.com. Its mode is cluster, and we have our config account as the Google service account. So when we're happy, we hit Control S to save, Control X to exit. And the last thing we need to do now is apply that change. So we type in kubectl, apply-f, and now the name of the YAML file. So config connect.yaml. We go ahead and hit enter, and it has deployed and configured the config connector. So from here on out, you can manage your Kubernetes applications and your Google Cloud Platform applications right from Kubernetes. So I hope this video showed you the importance of the config connector, how to set up your users and your IAM policy bindings, and how to configure the config connector using a YAML file. In this video, I'm going to show you around the container registry in the Google Kubernetes engine. So the container registry is just one single organized place that you or your team can manage your Docker images, you can do vulnerability analysis, and you can decide using role-based access control who has access to what images. So really, in a nutshell, it's a secure private Docker registry. You can build and deploy automatically. You can do in-depth vulnerability scan. So let's take a look. I'm in the Google Cloud Platform. I'm going to come up to the search bar, and I'm going to type in Container Registry. You'll get a product and page called Container Registry. Go ahead and click Container Registry, and you're brought into your Container Registry. It should look like mine. I have nothing in my registry right now. So what I want to do is pull down an Nginx image, tag it, and then push it to my container registry. So I'm going to come up, and I'm going to activate the Cloud Shell. And I'm just going to make this a little bigger so we can see it. So the first thing we want to do is download an image, the Nginx image, and then we're going to tag it and then push it to our own registry. So I'm going to say Docker pool Nginx. You can see it pulls the latest Nginx image, the official Nginx image. Now I need to tag it. So what that means is that I'm going to tag it as an image in my project. So I'm going to say Docker tag Nginx gcr.io/mywebapp314016 because that's the name of my project. And I'm going to call it Nginx as well. So I click enter. Now the last thing I need to do is a Docker push to gcr.io mywebapp314016 Nginx. So I hit enter. It pushes it up to my container registry. So let's go ahead and minimize the shell and do a refresh on our repository. Now you'll see an Nginx image. You'll see that its visibility is private. Let's go ahead and click Nginx image. And you're brought into the image name, its tags, when it was created, when it was uploaded, and the vulnerabilities. So it ran a vulnerability scan. If this is your first time, you may have to come over into settings and enable vulnerability scanning. So I'm going to come back to images now. I'm going to look at my Nginx image. So I'm going to click the folder, and then I'm going to click the image name. So I'm brought right into the digest details. It gives me opportunities for a pool command. So if I want to generate a pool command, it allows me to do that. I can also click vulnerabilities. So this is a beautiful thing about the registry is that it searches for vulnerabilities in your images. So if you look, it gives you a severity, it gives you a CVSS, the package it belongs to, and any documentation on that vulnerability. They're ranked from high, medium to low. And in this case, I have 2 high vulnerabilities, 14 medium, and the rest are low. So if I really wanted to dig into it, I'm going to have to take a look and see what these severities are and how I can mitigate these severities before I push to production. So I'm going to come back and I'm going to take a little bit more of a look at this image. So from here I can deploy. So I can deploy it to Cloud Run. I can deploy it to Google Kubernetes Engine or the Google Compute Engine. So that's another great thing about this container registry is that not only can I do vulnerability scanning, but I can automatically deploy from here as well. I can scroll down. I can look at my manifest in a JSON file. And this is the whole Docker image and repository in a manifest file. So I can come up. When I'm done with this image or I don't want to use this image anymore, I can click delete. And that permanently deletes the repository item. So I go ahead and click delete, and it deletes my image, and I have no images anymore. So if I click refresh, you'll see there's no matching results. So I hope this video showed you the importance of the container registry, how to pull an image down, tag it, push it to your container registry, how to do vulnerability scanning, and look at all the details of your image inside the container registry. In this video, I'm going to discuss node pools, and I'm going to show you how to create node pools in your cluster. So we know a node pool is just a group of nodes in your cluster that all have the same configuration. So when you create a cluster, the number of nodes and the type of nodes that you specify becomes the default node pool. You can also create additional custom node pools of different sizes and types. So once you're in the Kubernetes Engine console and under clusters, let's come up and click Create. We're going to create a standard Kubernetes cluster. So click Configure, and it's going to bring us into a cluster creation wizard. So our cluster basics, we're going to call it Cluster 2. It's going to be zonal, so it's only going to be in one zone. And our control plane version is going to be using the regular release channel. But this is what I want to look at, the node pools. So over on your left, if you expand the default node pool and you click Nodes, you will see the node settings that are created for the default node pool. So you'll see the image type is a container optimized operating system with containered. It's an E2, and it's an E2 medium of machine type. So that's your default pool. I come back up, I click default pool. I specify how many number of nodes that I want. So in this case, I can leave the number of nodes to 1, just for demonstration purposes, but you always want at least 3 or higher, because when you're doing upgrades, you'll always have uptime. You won't experience the downtime. You will if you have less than 3 nodes. But for demonstration purposes, I'm going to leave it at 1 node. But I also want to add another node pool. So I'm going to click Add Node Pool, and you'll see Pool 1 pop up on the left-hand side. So let's go ahead and expand Pool 1, click Nodes, and here we can create new settings for a whole different group of nodes. So for image type, I'm going to choose Docker, so Container Optimized Operating System with Docker. And I'm going to choose a E2 Micro. So once I'm happy with this, I go ahead and I can click Create. Now that'll create the cluster with my default node pool and Pool 1. Or I can add, again, another node pool by coming up to the top and clicking Add Node Pool. I'm going to leave the 2 node pools, default pool and Pool 1, and I'm going to come down and click Create. It submits the job, and you can now see my new cluster, named Cluster 2, is starting to be created. So let's click Cluster 2 and take a deeper dive into this cluster that's being created. So while it's being configured, we can still look at some of the details, and we're interested in nodes. So if I click Nodes, you'll see that this cluster now has 2 node pools. It has the default node pool, and that's some E2 medium with a container optimized operating system. And Pool 1 is an E2 micro with a container optimized operating system with Docker. So right now, the number of nodes are both set to 0 because it's still deploying. But I'd expect to see 1 node in my default pool and 3 nodes in Pool 1 because that's the setting that we set in each default pool. So after the cluster is deployed, we should be able to take a look and see the number of nodes increase with each node pool. So now it's deployed, it's doing a health check, and that's the last step needed to deploy that cluster and the node pools. You can now see the number of nodes have updated to 1 for the default pool and 3 for pool 1. It's just estimated because the health check hasn't finished yet, but it will. So now you can see how you can just deploy multiple different types of node pools in a cluster. And from there, if we wanted to make any changes or any edits to these node pools, we can just come and click the name of the pool that we want to change. It brings us into details about this pool. So once it's complete, you'll see the number of nodes change from 3 estimated to 3. Now we know it's up and running. We can come up and we can click edit, and we can edit some of our details like the number of nodes. We can turn on auto scaling. We can specify the zones that we want this node pool in. We can change the image type. Right, so these are the things that we can edit in the node pool. So I hope this video showed you what a node pool is, the difference between the default node pool and creating a new node pool, and how to deploy your clusters with multiple node pools and edit those node pools after the cluster has been deployed. In this video, I'm going to discuss pods and deployments in the Kubernetes Engine platform. So we know pods are the smallest, most basic deployable object in Kubernetes, and it's a single instance of a running process in your cluster. A pod will contain 1 or more containers, and when a pod runs multiple containers, those containers are managed as a single entity and share the pod's resources. So how do we create pods? Well, a pod is ephemeral, so it's not meant to last forever. And it's not recommended that you create individual pods directly. You create a set of identical pods called replicas to run your application. And a set of replicated pods are created and managed by a controller. And in our case, that controller is going to be a deployment. A deployment is a set of multiple identical pods with no unique identities. A deployment will run multiple replicas of your application and replace any instances that fail or become unresponsive. So once you're in the Google Kubernetes Engine console, I have a cluster running. You should have a cluster running as well. We're going to do a deployment, and we're going to deploy some pods out to our cluster. So click the cluster name to be brought into the cluster information screen. And up on the top, you see deploy. Go ahead and click deploy. So this deployment is a controller that allows us to create pods with the container images on them. So in this case, I'm going to just deploy Nginx and the latest version of Nginx. But if I wanted to add more containers, I can come down and click Add Container, and it would add more containers onto this pod. I'm happy with the one right now. It's just Nginx latest. I'm going to come down and click Continue. You'll see the application name gets populated. It fills in the default namespace. Then it provides some labels, so key being app and the value Nginx1. And if you want to view the configuration YAML, you can click View YAML, and you'll see here is the YAML output. I want 3 replicas. The app is Nginx1. The container, I'm using the image of Nginx latest. So I go ahead and click Close. I specify my cluster, and that's the cluster that I'm going to use is the one I already created. If you want to create a new cluster, you can just click Create New Cluster, and then click Deploy. So it's deploying the Nginx image out. It's using the existing cluster, and then the deployment succeeded. So it was very quick. So we can roll down. We can look at it. It gives us all of our details. So the managed pods, there's 3 pods. They're all running, and they're all running the Nginx application. And if you come up to active revisions, you can see the summary. So it's using the Nginx latest image, and 3 out of 3 pods are running it. If you come up You can see all your replicas. You can come up and click delete. You can edit, or under actions, you can auto scale it. You can expose it. You can use rolling updates, or you can scale it. So I hope this video showed you the importance of a pod, how to create a pod using deployments. And once you've created your deployment, how to look at all the details, then possibly delete your deployment, or do some actions like auto scaling, or expose it to a public IP. In this video, I'm going to discuss working with services and exposing your applications using these services. So a service is used to group a set of pods endpoints into one single resource. So if you're thinking what I'm thinking, load balancing right away. So you can configure various ways to access this grouping, and there are 5 types of services. Cluster IP, which is the default service, node port, load balancer, external name, and headless. So a cluster IP exposes a service on a cluster internal IP. Node port exposes a service on each node's IP at a static port. And a load balancer will expose the service externally using a cloud provider's load balancer. So in this video, we're going to expose using a load balancer. So the first thing I need to do on my node is to deploy a pod with an Nginx container. So I'm in my cluster. I'm going to come up and click deploy. I'm going to use an existing container image. It's the official Nginx image. I'm going to scroll down. I'm going to click continue. I'm going to leave the application name the same, the default namespace the same. I'm going to scroll down and I'm going to click deploy. So now I want to deploy this Nginx out, and then I'm going to use a load balancer service to expose it externally. So now you can see that it's successful. You see the green checkbox, and you see it right in front of your face, a little gray bar that says, to let others access your deployment, expose it to create a service. So I'm going to go ahead and click expose, and I'm brought into my exposing console. So here's where we do our port mapping. So I want to port 80, and I want to send it to port 80. Now, if I were serving traffic internally on port 3000, I could map port 80 externally to port 3000 internally. I'm using port 80, both external and internal, so I can just set both ports to 80. And under service type, you'll see cluster IP, node port, and load balancer. So cluster IP will expose it on an internal IP in the cluster. Node port will expose it on the same port of each selected node. And a load balancer is going to create a load balancer with an external IP. So let's go ahead and click load balancer. We can give it a service name. I'm going to leave the default name. You can also click view YAML. So click view YAML just to get a look at the YAML file that we could copy, we could download and use for future use. So you'll see that it is an Nginx service, and we're mapping port 80 to port 80, and it's of a type load balancer. So I click close. I go ahead and click expose, and then I wait for the load balancer to fire up and give me an external IP. Once it's complete, you see the green checkbox. You come down, it shows you a bit more details, so it shows you the cluster name, the namespace, any labels, the logs, the type of load balancer, and it gives us our external IP. So 34.133.61.209, and it's on port 80. If you come down, you get your internal cluster IP. They show you your external load balancer again, and a link to the load balancer in Google Cloud Platform. You see your deployments are 3 of 3, all your serving pods. So now, once we send a request to that external endpoint, it's going to be load balanced amongst these 3 serving pods. So I'm going to come up, I'm going to click on my external endpoint, and right away I'm brought into Nginx. So I just hit one of those 3 pods. If I refresh, and I keep doing it again, and keep reloading, I'm still hitting one of these 3 pods. So I'll come back to my console, You can see a subsequent CPU usage spike, so you know I'm hitting those pods. But we don't really know which pod we hit, and that's the beauty of the load balancer. So when I get a lot of traffic, I can spread the load over those 3 serving pods. So I hope this video showed you what a service is, the different types of services, and how to expose your pods using a load balancer service in the Google Cloud Platform. In this video, I'm going to talk about and demonstrate stateful sets in the Google Kubernetes engine. So stateful sets are just a set of pods with unique, persistent identities and stable host names that the Google Kubernetes engine maintains regardless of where they're scheduled. The state information and other persistent data for any given stateful set pod is maintained in persistent disk storage, and that persistent disk storage is associated with the stateful set. So stateful sets use an index for the identity and ordering of the pods. So if we created a pod called app and it was a stateful set pods, then they'll be deployed in sequential order, and they'll be named app-0, app-1, and app-2. And when that app pod specification is changed, its pods are gracefully shut down and recreated in an ordered way. So app-2 will be terminated first, then app-1, and so on. So it's created ascending and it's shut down descending. So let's go ahead and look at creating a stateful set. Stateful sets use a pod template which contains the specification for the pods. The pod specification will determine how each pod should look, what application should run in it, and which volumes should mount, and things like labels and selectors and more. So let's take a look at a pod template. So here's a service and stateful set manifest file. So if we look through it in this example, a service object named Nginx is created. And that's indicated by the metadata field where you see the name Nginx, and the labels, it's called App Nginx, and selector App Nginx. So the service exposes port 80 and names it web. A stateful set is also created. So you can see a stateful set named web is created with 3 replicated pods. The pod template, as specified by spec:template, indicates that its pods are labeled App Nginx, and the pod specification also indicates that the pods run one container called Nginx, and it runs the Nginx Slim image. The container image is hosted by the container registry. The pod specification uses the web port opened by the service. So in summary, the pod specification contains instructions to label each pod as App Nginx. In each pod, run one container named Nginx, run the Nginx Slim image at version 0.8, have pods use port 80, and save the data to the mount path itself. So as we can see, the mount path is user share Nginx HTML, and there's a volume claim template in here as well. So I'm going to go ahead now, and I'm going to implement this template. So once I'm back in my console, I'm going to come up and activate the Cloud Shell, and I'm going to run everything in the Cloud Shell. So I copied the template from the Notepad file, and I'm going to create a YAML file in the Cloud Shell. So I'm going to say nano stateful.yaml. I'm going to paste in the code. I'm going to click Save and Exit, and that's just the code we just looked at in the Notepad file. Now when I'm ready to roll it out, I just run kubectl create-f stateful.yaml, hit enter, and it's been created. So the service is created and the stateful set has been created. So with that being said, let's come back into the console, click on workloads, and let's take a look at our workloads. So you can see right now we have a stateful set called web that we just deployed. So if you go ahead and click web, you can scroll down, you can see all the information about your stateful set, the cluster it belongs to, the label selector, any persistent volume claims. And if you come down to manage pods, here's what we're talking about. So web-0, web-1, web-2. If these were to shut down, they would shut down web-2 first, then web-1, then web-0, and then recreate in the reverse order. So I hope this video showed you what a stateful set pod is, how to create a stateful set, and how to go in and view details about your stateful set. So from here, we can scale our stateful set, we can delete our stateful set, or we can perform any edits to our stateful set that we wish to perform. In this video, I'm going to demonstrate the usage of a daemon set in your Google Kubernetes cluster. So a daemon set will ensure that all your nodes run a copy of a pod. And as nodes are added to the cluster, pods are added to them. And as nodes are removed, subsequently those pods are also deleted. Daemon sets are useful for deploying ongoing background tasks that you need to run on all or certain nodes and don't require user intervention. Things like storage daemons and log collection daemons. And one of those log collectors, called FluentBit, is what we're going to implement today. So like other workload objects, a daemon set manages groups of replicated pods. However, daemon sets attempt to adhere to a one pod per node model, either across the entire cluster or a subset of nodes. As you add nodes to a node pool, daemon set automatically adds those pods. Daemon sets also use a pod template. This contains specifications for its pods. So the pod specification determines how each pod should look, what applications should run, what volumes it should mount, and what labels and selectors it should look for to deploy on specific nodes. Let's take a look at a pod template. So here you'll see a daemon set pod template with the metadata named FluentBit, and here's the spec field. So it's selectors, match the labels. So we want to match the label named FluentBit. Our template metadata label is also FluentBit. But under spec node selector, you'll see type prod. So this says that node label selector will determine on which nodes pods should be scheduled. In this case, these pods are only going to be scheduled on nodes that have the label type prod. And on those nodes, pods will be deployed. It'll pull down the FluentBit image 1.6 onto a container, and it requests its CPU and its memory requirements. So I'm going to copy this pod manifest file, and I'm going to go into my Google Cloud platform. Now, the first thing I want to show you is my cluster. So if I click my cluster, you'll notice I have two node pools. So if I click nodes, I have my default pool and my pool 1. Default pool has one node. Pool 1 has 3 nodes. So if I click default pool and I scroll down and I look at metadata, there is no metadata that says that this is of type prod. So if I scroll back up and go back, and now I click pool 1 and I scroll down, I can see that there's a Kubernetes label here and it's of type prod. So this daemon set pod template should deploy on this node pool, pool 1. So I'm going to click back and I'm going to open up my Cloud Shell. So I come up and I click Activate Cloud Shell. It opens up on the bottom. I just expand it so I can see it a little better. And now I'm going to create that pod template. So I'll type nano Richard daemon set. I'll paste in my daemon set pod specification. Control S to save, Control X to exit. And now I'll apply it. So kubectl apply -f Richard daemon set. And I hit enter. Now you'll see the daemon set.apps FluentBit has been deployed. I can minimize my Cloud Shell. Now I come over and look at workloads. So once I click workloads, I'll see FluentBit is now listed under workloads. It's of type daemon set, and its pods are 3 of 3. So if I click FluentBit and I go in, I can dig a little bit deeper into this daemon set, and I can see all the details. I can see the CPU, memory, disk usage, the cluster, its namespace, the pods that it's scheduled on, the pods that it's desired on, and the pods that it is ready. And they're all 3. I have 3 pods in that node, and they're all deployed to each one of them. You can see the pod specification labels, fluent bit, and the container fluent bit, which we pulled down that image version 1.6. You can also see what managed pods this is running on, and if it was exposed to any load balancers or any internal nodes, then we would see it here as well. So I hope this video showed you what a daemon set is and how to deploy your daemon set and how it can be really useful for these pods that can perform those background tasks like storage and log collection. In this video, I'm going to demonstrate how to use a config map in the Google Kubernetes engine. So config maps are just easy way to separate your configuration from your infrastructure. Config maps will bind your configuration files, environment variables, port numbers, and other configuration artifacts to your pod's containers and system components at runtime. So config map allows you to separate your configurations from your pods and your components. That keeps your workloads portable. So in our example, we are going to pass in environment variables. So Kubernetes follows the approach to allow you to inject environment variables at runtime. So we're going to inject some environment variables into our pod at runtime. So first we have to create a config map. Then we create our pod and tie that pod to a config map. And the beauty is that we can use this config map over and over as we see fit. So once I'm in my Google Kubernetes cluster, I'm going to come up and I'm going to click Activate Cloud Shell. My shell opens up at the bottom. It provisions my shell. So once my terminal shell is open, the first thing I need to do is create my config map definition. So I'm going to create a file called nano Richard config map. And I'm going to paste in my code and we're going to take a look at it. So I come up to the top of my script and we can take a look at our code. It's of kind config map. It's API version 1. It's metadata. It just gives it a name. We're going to call it app config. Its data says channel, my channel, and I'm giving another environmental variable called Slack config, and it's passing in a webhook for a Slack URL. So I'm going to go ahead and click Control S to save, Control X to exit, and I'm going to go ahead and do a kubectl apply-f Richard config map. I hit enter. My config map app config has been configured. Now I need to create a pod and tie it to that config map. So I'm going to create another file and I'm going to call it Richard pod. And I paste in my code. So this time you can see the kind is of pod. The name is app. And I just pass in some specs for my containers. So I want a bash environment. And under env from, so where's our environmental variables coming from? We have a config map reference and we're referencing the name of the config map we just created. So I hit Control S to save, Control X to exit. I type in kubectl apply-f Richard pod, and it creates my pod/f. So now the pod is up and running. I'm going to log into that bash environment and see if our environment variables are available. I can type in kubectl exec-it Richard app --bash. I get my bash prompt. I type in env to get my environment variables. I can see all the Kubernetes environment variables. But if I scroll up, you see the environment variables that I selected, channel and Slack config. So I hope this video showed you how to create a config map, how to create a pod and tie it to that config map to separate your configuration from your hardware and your infrastructure. In this video, I'm going to demonstrate the use of persistent volumes in your Kubernetes clusters. So remember, a persistent volume is a resource, and it's used to manage durable storage for your cluster. In the Google Kubernetes engine, a persistent volume is typically backed by a persistent disk. The persistent volume lifecycle is completely managed by Kubernetes, and a persistent volume can be dynamically provisioned, so you don't have to manually create and delete that storage. Now, persistent volume resources are cluster resources that exist independently of pods. So this means that the disk and the data represented by a persistent volume continue to exist as the cluster changes and as pods are deleted and recreated. Persistent volume resources can be provisioned dynamically through persistent volume claims, or they can be explicitly created by a cluster administrator. We're going to use a persistent volume claim. So that's a request for and a claim to a persistent volume resource. So once we're in our Google Cloud Console, I want you to come up and open up the Cloud Shell. So click Activate Cloud Shell, and we're going to open up our shell. Mine's minimized, so I drag the screen up so I can see it a little bit better. Now I'm inside my Cloud Shell. So the first thing I need to do is create a manifest file. So I'm going to create a manifest file. I'm going to call it Richard Volume, and I'm going to paste in the following code. So you see the API version is version 1. Its kind is persistent volume claim. So we're telling it that this is a persistent volume claim. The metadata name is Richard Volume. So that's what we want to call that volume. Its spec, it's a read-write once access mode, and it requests 30 gigs of storage. So I'm going to go ahead and click Control S to save, Control X to exit, and I'm just going to run kubectl apply-f Richard Volume, and you can see that persistent volume claim Richard-vol has been created. So let's come back to our console. We can exit out of the Cloud Shell, and once we're in our Kubernetes engine console, come over to the left-hand side and select Storage. So now I click Storage. You'll see that the Richard-vol has been created and it's bound. We know that it's bound because it says bound in the phase, but it's also listed under persistent volume claim. So not only is the persistent volume created, but it's also claimed. So let's go ahead and click the name of our recently created persistent volume, and it brings us into more details. So you can see that it belongs to the My Cluster cluster. It's in the default namespace. You see your annotations that tells you if the bind has been completed, if the bound has been done by the controller. You see its phase, its requested access mode, and its storage class of standard. You even have a link to the physical volume that you can click on to view that physical volume if you wanted to take a deeper dive into that volume. We can also come up to events. Any events you'll see. So like we said, that persistent volume lifecycle is managed by Kubernetes. And as you can see it here, any events in that provisioning is displayed here. So in this one, it tells us that it's successfully provisioned the volume. If we were to make changes to that volume, we'd see them here under events as well. We can click YAML, and we can see the output of that persistent volume that we created. So we can see the metadata and all the annotations, all the managed fields, all the manager. So who is the manager? What was the operation? We did an update. A lot of information about the specs that we specified earlier. 30 gigs of storage, read and write once, and it's bound to a pod. So I hope this video showed you the importance of persistent volumes, why you'd want persistent volumes, and how to make a persistent volume claim. And that's just a simple request for and a claim to a persistent volume resource. So in this course, we've examined managing Google Kubernetes Engine. We did this by exploring how to use the GKE dashboard and managing clusters, creating and using volumes with deployments, and creating secrets to store sensitive data, using config connector for Kubernetes and viewing container image repository, and managing node pools, creating pods, and managing pod deployments. We also created, edited, and deleted services, created stateful sets, daemon sets, and a config map, and used persistent volume and dynamic provisioning. In our next course, we'll move on to examine implementing Google App Engine, or GAE. Now let's dive right into some App Engine features. One of the main features is that it supports popular languages. So it supports Node.js, Java, Ruby, C#, Go, Python, or PHP. And if you're so inclined, you can bring your own custom language runtime. It's open and flexible, so you can bring any library and framework by supplying a Docker container. It's fully managed, so you only have to worry about the code. You can let Google worry about the infrastructure side of things. You have application diagnostics, so tools like cloud monitoring and cloud logging will monitor the health and performance of your application, and integration with Cloud Debugger and error reporting will be used to diagnose and fix your bugs. Application versioning, so you can have different versions of your app hosted in different environments. You could have a testing environment, a staging environment, and production environments. Traffic splitting, so you can route incoming requests to different app versions, or you can do incremental feature rollouts. Application security helps you safeguard your application by implementing access rules with the App Engine firewall and using SSL and TLS certificates on your custom domain at no additional cost. And you get that services ecosystem. So it's a growing ecosystem of Google Cloud services from your application that include an excellent suite of cloud developer tools. So App Engine is definitely one for a developer who wants to develop and launch their application and not worry about the infrastructure side of things. Google App Engine environments. So with Google App Engine, it's a fully managed serverless platform for you to develop and host your web applications and scale them as much as you need to. You can choose from your language of choice, develop your apps, and then let App Engine provision the servers and scale your infrastructure. So you can run your applications in the standard environment or the flexible environment. You can also choose to simultaneously use both environments for your application, and that'll allow your services to take advantage of each environment's individual benefits. So let's take a look at the App Engine standard environment. So the App Engine standard environment is based on container instances, and these are running in the Google infrastructure, and they're pre-configured with one of the runtimes that you choose to deploy in. It's easy to build and deploy. Your applications will run reliably even under a heavy load with a large amount of data, and you can run in a secure sandbox environment. So by using your application in a secure sandbox environment, the App Engine standard environment will distribute requests across multiple servers and scale your servers to meet traffic demands. Your application will run within its own secure, reliable environment. And that's our definition of a sandbox. Using the standard environment. So when will you want to use the standard environment? When would you choose the standard environment? Application instances run in a sandbox using the runtime environment that you chose. The standard environment is optimal for applications that have source code written in specific versions of the supported programming languages. So Python 2.7, 3.7, 3.8, and 3.9, for example. Or if you're going to use PHP 5.5, 7.2, 7.3, or 7.4, you would want to use the standard environment. And you can get the full list on the Google website. It's intended to run for free or a very low cost. So you only pay for what you need. And it can experience sudden and extreme spikes of traffic, which require immediate scaling. So if any of this looks like your application, then you may want to use a standard environment. The App Engine Flexible environment, on the other hand, allows you to focus on what you do best, writing code. So based on the Google Compute Engine, the App Engine Flexible environment will automatically scale your app up and down while also performing load balancing. So some of the features of the flexible environment are the customizable infrastructure. So with the flexible environment, you're using Compute Engine instances, so therefore you can take advantage of the different infrastructure availabilities in the Compute Engine. You have performance options, so you can take advantage of CPU and memory configurations. You specify how much CPU and memory your application is going to need. Native feature support, so microservices, authorization, SQL databases, logging, all these things are fully supported and by default. And you get managed virtual machines. So App Engine will manage your virtual machine. So if the thought of having virtual machines scares you, not to worry, because App Engine will manage your virtual machines for you. And that includes health checking, any updating, any patches, and the like. Using the flexible environment. So application instances run within Docker containers on the Compute Engine virtual machines. So when would you want to use a flexible environment? The flexible environment is really intended to be complementary to the standard environment. And if your application is running in the standard environment, it's not usually necessary to migrate the entire application to the flexible environment. So instead, you identify the parts of your application that would, say, require more CPU or RAM, or they need specialized third-party library or programs, or your application will perform actions not possible using the standard environment. So these would be ideal opportunities to move pieces of your application to the flexible environment and leave other pieces of your application in the standard environment. So once you identified those parts of the application, you create a small App Engine service that uses the flexible environment to handle just those parts. And that's why it's important to decouple your architecture in your application. Comparing App Engine to the Compute Engine. So the App Engine Flexible environment has the following differences from the Compute Engine itself. Flexible environment VM instances are restarted on a weekly basis. You always have root access to the VM instances. So by default, SSH access to the VM instances in the flexible environment is disabled. But if you choose, you can enable root access to your app's VM instances. Code deployments can take longer because these container images are built using the Cloud Build service, and the geographical region of your flexible environment is determined by the location that you specify for your App Engine application. In this video, I'm going to show you how to install an SDK for the App Engine. So I have two environments I can choose from. I can choose between a standard environment and a flexible environment. In the standard environment, I can use Python, Java, Node.js, PHP, and Go. Whereas in the flexible environment, I can use Python, Java, Node.js, Go, Ruby, PHP, .NET, and any custom runtimes. So I'm going to use Go. I'm a Go developer, and I want to take advantage of a flexible environment. So the first thing I need to do is come under Flexible Environment and click Go. This should give us a bit more information about installing the Go SDK for App Engine. So it lists a few prerequisites. First, it wants to make sure that your environment has Go. So I'm using my local Windows machine. I've already installed Go. If you're using any other type of framework or runtime, you would have to install those as a prerequisite before we get into actually setting up the SDK for Google App Engine. So Go is installed. So I'm going to leave here and I'm going to go into my gcloud SDK command line tool. So as you can see, I'm in the gcloud SDK. And I just want to make sure that I have Go installed. So I'm going to type in Go version. It brings you back my Go version of Go 1.16.5. So as a prerequisite, Go is already installed. Now I want to go and get that App Engine SDK for Go. So I'm going to type in gcloud components install app-engine-go. Depending on your framework, this could look different. If you're using PHP or Python, obviously you're not going to install the App Engine Go, but you would install the App Engine SDK for your framework. So I'm going to go ahead and click Enter. It starts to spin up the installation of the App Engine SDK for Go. It pops me up a new window. And now it says your current Cloud SDK is version 339.0.0, and we're installing components from version 339.0.0. It says these components will be installed. So the App Engine Go extensions, the Cloud Data Store emulator, the gRPC Python library, and the gcloud app Python extensions. So I'm going to open up this window a little bigger, and then it'll ask me, do I want to continue? I'm going to go ahead and click yes, or type in Y. It creates an update staging area and now begins the installation process. So it installs the App Engine Go extensions, the Cloud Data Store emulator, and the Python library and extensions, creates a backup, and activates the new installation. It performs some post-processing steps, and then the update is done. So I push any key to continue, and it brings me back into my Cloud SDK window. So I hope this video showed you how to install the App Engine SDK for the development framework of your choice. In this video, I'm going to show you how to set up your Cloud Run environment in the Google Cloud Platform. So remember, Cloud Run is that managed compute platform and allows us to run containers via requests or events, and it's completely serverless, so you don't worry about any of the underlying hardware. So once we're in our Google Cloud Platform, there's a couple things we need to do. We need to enable the API. So up under Search Products and Resources, type in Cloud Run API. You'll see under Marketplace, API, and it says Cloud Run API. Let's go ahead and click Cloud Run API. You're brought into the Cloud Run API page. So if we look at the overview section, it says Run stateless HTTP containers on a fully managed environment. Cloud Run is a managed compute platform that enables you to run stateless containers that are invoked via HTTP requests. So in order to use it, we need to enable the API. So let's come up and click Enable under the Cloud Run API, and this will enable our API. From there, after it's enabled, we should see the button change now, and we're brought right into the Cloud Run API console. So here's where we can create credentials for our API. So to use this API, it says you may need credentials. So let's go over and click Create Credentials. And now it's saying, what API are you using? Different APIs use different authentication platforms. So we're going to click the drop down, and we're going to come down to Cloud Run. So it's the Cloud Run Admin API. Then it says, what data will you be accessing? And you can see a little note that says this Cloud Platform API is usually accessed from a server using a service account. So what data are we accessing? Are we accessing user data? So data belonging to a Google user? Or application data? So in our case, we're only going to be accessing application data. I'm going to click Application Data. Then I get a new question. Are you planning to use this API with Compute Engine, Kubernetes Engine, App Engine, or Cloud Functions? So no, in this case, I'm not using them. I'm going to click Next. Now it asks me to create a service account. So I'm going to create a service account. I'm going to call it Cloud Run. And I'm going to give it a description of Cloud Run Service Account. I come down and click Create and Continue. Now I want to select the role. So under Role, I'm going to type in Cloud Run. And now I'm going to select Cloud Run Admin. Now I click Done, and we've successfully created a service account for the Cloud Run API. So now at this point, you'll see the service accounts, right? These are the credentials that we can use to access the API. So now that we've taken care of creating the service account and enabling the API, there's a couple more things that we can look at in Cloud Run. So let's come up to Search Products and Resources, and let's type in Cloud Run. So we go ahead and we click Cloud Run. It brings us into our Cloud Run console, and from here is where we can start the process of running our containers, right? So we can click Create Service to enable the Cloud Run API, or we can take the quick start. So when I click Create Service, this enables the Cloud Run API, and I'm brought right into creating a service right away. So we enable that API when we create our first service. So I'm not going to create the service right now. I'm going to come up and click the back arrow, come back into our Cloud Run console again, and you'll see one more thing called Manage Custom Domains. So if I have domains that I want to bring in, I can click Manage Custom Domains, and I can start mapping my domains into my Cloud Run service so I can perform some DNS. So I'm going to go back to the service page, and now I'm back to my Cloud Run. So at this point, you'd want to start to create some services and enable the Cloud Run API. So I hope this video showed you how to turn on the Cloud Run API, how to create a service account, and how to work around the Cloud Run console for the first time. Now let's take a look at Cloud Functions. So Cloud Functions are pay-as-you-go function as a service. So FAAS, that's a new one, function as a service, and you can run your code with zero server management. So you get automatic scaling based on your load, built-in security, so that's at a role level and a function level, always based on the principle of least privilege, monitoring, logging, and debugging. There's no servers to manage, so you don't have to provision any servers, manage any servers, patch any servers, and you get the key networking capabilities for hybrid and multi-cloud scenarios. So some of the Cloud Functions' key features. So it offers a simplified developer experience and increased developer velocity. So it's much easier to use. You have a simple and intuitive developer experience, and you can write your code faster, and you can get your applications to market much faster. Right? You can develop faster by writing and running small code snippets that respond to events, rather than one big monolithic application. You only pay for what you use. So you're billed for your function's execution time to the nearest 100 milliseconds, and you pay nothing when that function is idle. If you were using a managed experience or a server and you're running your functions on a server, you're going to pay for compute engine time. But with Cloud Functions, you only pay when your functions actually run in this serverless environment. You can prevent lock-in with open technology. So you use open source framework and run your functions across multiple environments if you wish. And you can connect and extend services in the Google Cloud Platform. So Cloud Functions allows you access to all Google and third-party cloud services as building blocks. So maybe they trigger your code. Maybe they're a destination for your function. But you can connect and extend them with the code and move from conception to production with end-to-end solutions and complete workflows, all in a serverless function-as-a-service environment. Some more Cloud Functions key features is the end-to-end development and diagnosability. So from code to deployment, you can integrate monitoring and then you can get that full look into your application and diagnose any issues with Cloud Trace and Cloud Debugger. Automatic scaling, so you can go from 0 users to thousands or millions of users, and you don't even have to think about it. You don't even have to wake up at night. Cloud Functions will automatically manage and scale all the underlying infrastructure. That is not a concern of yours as a developer. So in saying that, there's no servers to manage either. And we can run code in response to events. So we can trigger our code from Google Cloud, Firebase, or Google Assistant. We can even call it directly from the web if we wish. So what type of cloud functions can we create? So there's two types of cloud functions. We have HTTP functions. So these are HTTP functions from standard HTTP requests. These requests will wait for the response and support handling of the common HTTP request methods like put, post, get, delete, and options. You can also use event-driven functions. So Cloud Functions uses event-driven functions to handle events from your cloud infrastructure. So things like a pub sub topic could trigger your function, or changes in a cloud storage bucket could trigger your function. HTTP functions. So HTTP function security levels control whether an HTTP function supports HTTPS only or HTTP and HTTPS by default. When you configure your HTTP functions so that they can only be triggered with HTTPS, users who attempt to use just unsecured HTTP will be redirected. So you can specify an HTTP function's security level during your deployment. You can use the gcloud command line tool and set the security level flag, or you can use the Cloud Console and check off the Require HTTPS checkbox. So if we want to force HTTPS, we can do it from the gcloud command line or from the Cloud Console. Event-driven functions contain two subtypes of functions. These are background functions. So event-driven functions written in Node or Python or Go or Java are sometimes known as background functions. And cloud event functions are event-driven functions written in .NET, Ruby, and PHP runtime environments. Background functions. So let's dig in a little bit more on these types of functions. Cloud functions are invoked indirectly from a pub sub topic or a change in a cloud storage bucket, and it can also be a Firebase event. It's important to note that background functions are supported for Node.js, Go, Python, and Java. Cloud event functions is the second type of event-driven function. It's similar to background functions, but it provides an industry standard event format. So conceptually, they're similar to the background functions, but the big difference is that the cloud event functions use this industry standard event format, and these are known as cloud events. Another difference is that the cloud functions itself invoke cloud functions using HTTP requests, and they can be reproduced elsewhere. So taken together, these differences enable cloud event functions to be moved seamlessly between compute platforms. We should also discuss function parameters. So cloud event functions are passed in a single cloud event argument that holds properties and metadata associated with the event that triggered the function's execution. Incoming cloud events are then converted into the language-specific representations shown using the function framework's libraries. Now let's look at a few more important notes about cloud functions. So naming cloud functions. Cloud functions have a name property and you set it at deploy time. Once you set it, it cannot be changed. The name of a function is used as its identifier and it must be unique within a region. Specifying dependencies. You specify your function's dependencies idiomatically based on the runtime that you're using. So they're going to be different depending on your runtime. And structuring source code. So in order for cloud functions to find the function's definition, each runtime has structuring requirements for your source code. It's recommended that you split up large multifunction code bases into smaller per function ones. In this video, I'm going to show you how to deploy your application to Google App Engine using the gcloud command line tool. So once you're in your Google Cloud platform, come up to the top bar and click Activate Cloud Shell. You'll see a Cloud Shell window pop up on the bottom. In my case, I have to expand it, and you get your black screen, and here's your shell. So now's the time to set your project. For most people, their project is already set. If you need to change your project to a different project, you can type in gcloud config, set project, and then the project ID of your new project. So I'm changing my project, and now you can see my prompt change with the new project ID. So I'm going to type in git clone and the URL, and it's a github.com Google Cloud Platform repository, and it's called Golang samples. So I'm going to deploy a Golang Hello World application. So I hit enter, it clones that GitHub directory, brings it into my shell, and now I change directories and I go into the Golang App Engine go11x/hello world directory. So now let's do a ls and let's look at some of the files in this directory. So you can see I have app.yaml, go.mod, helloworld.go, and helloworld_test.go. So let's take a look at helloworld.go. So I'll type in cat helloworld.go, and I can see the Go application. So I can see the function, and it's listening on port 8080. And if I come down and make a connection, print out hello world. So very simple hello world application. It's important to note that App Engine also uses the YAML files to specify a deployment's configuration. So in our case, if I do an ls, I see app.yaml. That file will contain information about the application, such as the runtime. So let's take a look at app.yaml. So I type in cat app.yaml, and I can see that this YAML file just specifies the runtime of Go 11 font. So let's test our application in the Cloud Shell before we deploy it. So I'm going to type in clear so I can get a wider screen to work with. And now I'm just going to type in go run dot, and it starts to run the application in the Cloud Shell. So it's defaulting to port 8080. It's listening on port 8080. Now I can come up and click Web Preview in my Cloud Shell title bar. And then I can click Preview on port 8080. That opens up a new browser window with Hello World. So I can see that the application works correctly. Once I come back to my Cloud Shell again, I can press Ctrl-C to interrupt and get back to my prompt. At this point now, we want to type gcloud app create, and it begins to create the application. It asks me, where do I want to deploy it? I'm going to go with US East 1, so I'm going to type in 18. And then it creates the App Engine application in the project I specified with the region I selected. Now it says success, the app is now created. Please use gcloud app deploy to deploy your application. So I'm going to type in gcloud app deploy. I hit enter, and now the deployment process will begin. It gives me my source, the target project, the target service, the target URL, and the target service account. Then it asks me if I'd like to continue. I select Y for yes. Then it uploads the 5 files to Google Cloud Storage. Then it begins to update the service, right? So it looks at that YAML file, it looks at the Go file, and it creates your full environment and deploys your application for you. This step, depending on how big your application is, could take a little while, but generally it's pretty quick. When it gets successfully implemented, we can copy our target URL and we can get right into that application via an HTTP endpoint. Now you can see that it updated the service it set the traffic split for the service to be default, and then it deployed the service to the HTTP endpoint. From here now we can stream the logs or view our application in the web browser. So if I want to type gcloud app browse and I hit enter, it tells me that the shell didn't detect my browser, and that's because I'm running it in the Google Cloud Shell, but it gives me a link to click instead. So I click that link, I'm brought to my Hello World application. So I hope this video showed you how to deploy your application, in this case it was a Golang Hello World application, to Google App Engine using just the gcloud command line interface. In this video, I'm going to demonstrate how to deploy a container image using Cloud Run. So once you're in the Google Cloud Platform and you're under the appropriate project, come up in the search bar and type in Cloud Run. And you'll see under Products and Pages, Cloud Run. So I'm going to click Cloud Run, and I'm brought into the Cloud Run console. So you'll see a big blue button that says clicking Create Service will enable the Cloud Run API. So that does two things for us that we want to do. We want to enable the Cloud Run API, and we want to create a service. So let's click the big blue button that says clicking Create Service will enable the Cloud Run API, or we can come up to the top bar and click Create Service. Both do the same thing. So I'll click Create Service, and now I'm brought in. The first thing I need to do is give it a service name. So I'm going to call it Nginx My Web App. So I'm just going to deploy an Nginx container and expose it on port 80 using Cloud Run. So I give it the service name of Nginx My Web App. I give it the region of US Central 1. Then I click Next. Here's where we choose our image. So we can deploy one revision from an existing container, or we can set up continuous integration, continuous deployment by continuously deploying new revisions from a source repository. For us, we're going to just deploy one revision from an existing container image, and it's an Nginx container image. So I'll come over to container image URL. I'll click select, and you can see it picks up my container registry. So you'll see in my container registry, I have demo containers, I have an App Engine container, and I have the Nginx container. I'm going to click the Nginx container, and then I'm going to come down and I'm going to click the latest revision. Then I'm going to click select. You can see the container image URL now gets populated. I can come down to advanced settings and expand the advanced settings and set the port. So what port do I want to run this container on? I'm going to run this on port 80. I look at the capacity, so how much memory do I want allocated? How much CPU? Again, we can leave these small because it's just an Nginx default web server page. But if it was a bigger web application, this is where you would increase your capacity requirements. You get request timeout, auto scaling, right? So we're scaling between 0 and 100 instances. I can come up. I can choose variables and secrets. I could add environment variables. I could add secrets. If I click connections, here's where I can enable HTTP2 connections, any Cloud SQL connections, and under security, the service account we're using, and a few more advanced features. So I'm going to bring the advanced settings back up, and I'm going to go ahead and click Next. So now it asks me, how do I want this service to be triggered? Do I want to allow all traffic? Do I want to allow internal traffic and traffic from a load balancer, or just internal traffic only? This is just a web server, so I'm going to allow all traffic. And under authentication, I'm going to allow unauthenticated invocations. Because as you can see, it says tick this if you're creating a public API or a website, which we are. Require authentication would be to manage authorized users with Cloud IAM. So if we were using some authentication with our application. I'm going to go ahead and click Create. It begins to create the application, it sets the IAM policy, creates the revision, and routes the traffic. Once it's complete, you can see it has your green check marks. You can see the name, how much traffic it's receiving, when it was deployed. On the container side of things, I have my image URL, and all the capacity settings that we set are here to view, right? And the URL itself to reach the application is displayed here as a clickable link. So if I click the URL, I'm brought into the Nginx default web server page. So I can see that container was pushed out successfully. From here, I can edit and deploy new revisions. I can check out the logs and see anybody who's connecting, what's actually going on inside the container. And when I'm finished, I can come back and click back to go back to the services list page. And when I'm completely finished, I can highlight my Nginx web app, come up to the top, click delete again, and now it's gone. So as quick as that, we deployed a simple Nginx container, but it could be any container you want. We deployed it using Cloud Run into a serverless environment. Then we deleted it when we didn't want it anymore. So I hope this video showed you how powerful Cloud Run can be when deploying your container images in a serverless environment. In this video, I'm going to show you how to deploy a Google Cloud function from the Google command line on your local machine. So right now I'm in the Google Cloud Functions console. I'm going to switch over to my shell inside my Linux workstation. Now I'm in my workstation. Here's where I want to deploy my function to the Cloud Functions in Google Console. So the first thing I'm going to do is create a directory. So I'm going to make a directory and I'm going to call it My Functions. I'm going to navigate to the My Functions directory. So I'm going to type in git clone and I'm going to clone the Google Cloud Platform Python doc_sample.git. So I hit enter. It's cloning the Python doc_sample. Once it's finished, I'm going to change my directory to the Python doc_sample functions hello world directory. So once I'm in here, I can do an ls and I can look at all the different functions and parts of the hello world application function that I'm going to deploy. So let's take a look at the code. So I'm going to do a cat on main.py. Here's our code. So if I go all the way up to the top, it's a big function. You can see that it will return a hello world once it's triggered by an HTTP endpoint. All right, we can come down, we can see all of our function, all the pub sub events, right? And that corresponds back to all those files we saw in the directory. So this is the function that we want to deploy. So I'm going to come back down, I'm going to type clear, and now I'm going to deploy the function. So I'm going to type in gcloud functions, deploy, hello get, because if you remember when we looked inside of that function itself, it was defined as hello get, and it was a request. Its runtime is Python 3.9. Its trigger is HTTP, and we're going to allow unauthenticated. So if I go ahead and I hit enter, you can see now that it's created. I have the green check marks. The name is hello get. It shows me my region. The trigger, the runtime, so everything we set in the command line. The memory it has allocated, the function it's executing, and when it was deployed, and the authentication method. Under Actions, if I click the three dots, I can copy the function, test the function, or view the logs. So I'm going to come out and I'm going to click the name, hello_get. Now I'm brought into that function, and I can see a lot of the invocations and a lot of different metrics. I can also see details of my function, the source of my function, and it shows me my actual function, any variables Under trigger, it gives me the URL. So if I click the URL, I triggered the function because I got a hello world back. Permissions, so all the members and service roles. Logs, so it shows the build logs, all the logs that deal with the deployment of the function itself, and testing, so I can test here as well. So I'm going to come back to metrics. I'm going to come back up and look at invocations, and you can see that one invocation is now registered, and it was registered as an OK. So I'm going to go back to our page and look at our function again. So once it's complete, you can see that it's green checkbox. We tested it and everything seemed fine. So I hope this video showed you how to get your function onto your local machine, build it, deploy it, and send it to Cloud Functions so that it can be invoked, whether it's HTTP or event invocation. But you can do all that function as a service creation from your local command line. In this video, I'm going to demonstrate how to create a cloud function that responds to events from the Google Cloud Platform. So I'm in my Google Cloud Platform and I'm on the dashboard for my web app. We want to go up to the search products and resources, and let's type in Cloud Functions. You'll see a product page called Cloud Functions. Let's go ahead and click it, and we're brought right into the Cloud Functions page. So we want to create a function that responds to an event. And the event we're going to choose is when someone uploads a file to a storage bucket. So let's go ahead and click Create Function, and let's give it a name. So I'm going to change the name. I'm going to call it Storage Function, with a random number at the end of it. And I'm going to choose my region. So what region do I want this function to run? I'm going to choose US Central 1. Our trigger type. So it can respond to HTTP triggers. If I choose the drop down, I can choose Cloud Pub Sub events, Cloud Storage, Cloud Firestore, Google Analytics for Firebase, Firebase Authentication, Real-Time Database, and Firebase Remote Config. I'm going to choose Cloud Storage, so I select Cloud Storage. Then I choose an event type. So I click the drop-down button, and I can choose between an archive, a delete, a finalize and create, or a metadata update. So anytime one of these events occur in the cloud storage bucket that I'm about to choose, this will fire off this function. I'm going to choose finalize and create. So anytime that we upload to that storage account, we will make this function trigger. Under bucket, I click browse. So here's our bucket. So I can come up and click create a new bucket. It brings me into the create a new bucket wizard. So here I can just call it storage account, and it has to be a random name. Click continue. Do we want it to be multi-region, dual region, or just a regional? I'm just going to choose regional, and I'm going to put it in US Central 1. So I come down to US Central 1. I choose US Central 1. I click continue. So choose a default storage class. We're going to choose standard. Click continue. Prevent public access. We are going to uncheck this. This is just going to be a public bucket for demonstration purposes. Click continue. And we can come down and click create. So that creates our bucket. From here, we can come down to select, and that pre-populates the bucket field with the bucket we just created. So I'm going to click save. I'm going to go down and I'm going to click next. So here's the function itself. It's going to be, this is a sample function. This could be any function, right? In our case, it's just going to be a function that runs when we make a change to a cloud storage event. So it just spits out processing file in the console log. It's a Node.js runtime, and its entry point is hello GCS. So I'm going to click deploy, and this will deploy our function. You'll see on the bottom it says creating function. Then we're brought into our Cloud Functions console, and you can see our function being created. You can see the name of the function, the region, its trigger, so the bucket that we chose as the trigger, its runtime, its memory allocation, the executed function, and its last deployed date. Now you can see the function has been deployed. It has the green check marks. Now we want to go and upload a file to our storage account. So let's come up, and in the search bar, let's type in storage, and you'll see a page called Cloud Storage. Go ahead and click Cloud Storage. You'll see all your buckets. So I know that the bucket that I created my trigger from was storage account 281-87129. So I'm going to click the bucket name. I'm going to click Upload Files. I'm going to find a file to upload. It begins the upload. The upload is successful. At this point now, our function should be triggering. So let's come back up to the Cloud Functions page. So let's search for Cloud Functions. Click the Cloud Functions link. Now we're brought back to our familiar Cloud Functions dashboard. Come over under Actions and click the three dots, and let's click View Logs. So now we're going to go into our logging to see if the function actually ran. So this is the logs for the function. We can see under our logs that storage function 3928, and if we click the logs itself, we'll see that the storage function execution started. There's a log entry for when it actually processed. So it says processing file, and we can come down and view the last log that just says that the function execution took 132 milliseconds and it finished with the status of OK. So there you go. We have it. We just uploaded to our storage account, and that event triggered a Cloud Function. So I hope this video showed you how to incorporate events with your Cloud Functions to create really decoupled and powerful applications. In this video, I'm going to demonstrate how to create a pub sub topic and subscription to monitor changes to your Google Cloud Storage bucket. So pub sub makes it easy for you as a developer to build highly functional and complex decoupled applications in the cloud. So with pub sub, publishers and subscribers are decoupled, and they don't even know about each other's existence. Subscribers express interest in certain topics, and the publishers send a message to this topic. So in this video, I'm going to create a pub sub topic and subscription that looks at a cloud storage account and gets a message anytime that a change has been made to a cloud storage bucket. So once we're in the Google Cloud Platform console, come up to the search bar and let's type in pub sub. You'll see a product page. It says pub sub. Go ahead and click it, and you're brought into the pub sub page. So we have topics and we have subscriptions. So the first thing we're going to do is use the gsutil to create a notification topic for our bucket. So let's come up to the big blue toolbar and click Activate Cloud Shell. And let's open up a shell window at the bottom, and here's where we can run our commands. So I'm going to clear my screen so we can take a better look at everything that we have. Now my screen should look like yours, and I have a terminal window ready to go. I'm going to type in gsutil notification create -t, and now I type in the name of my bucket. So in this case, it's going to be storage account 281-87129. I hit enter. You'll see that it creates a pub sub topic and a notification for this bucket. So from here, we can close our terminal shell. And now let's do a refresh. So come up and click refresh. And you'll see now that I have a Richard Cloud topic that I just created. So I'm going to go ahead and click Richard Cloud topic. And you'll see that it says the topic has no subscriptions and messages published will be lost. So we need to add a subscription. So I'm going to come and click Add Subscription. I'm going to give it a subscription ID. So Richard Cloud Storage and just a random number. The delivery type is going to be pool or push. So if it's pool, we have to request the pool. And if it's push, we're going to push it to an endpoint. We're going to use a pool delivery. The expiry period for this message is going to be 31 days after inactivity. So if there's nothing going on this message, after 31 days, we'll expire it. The acknowledgement deadline is 10 seconds. I'm going to come down. I'm not going to enable dead lettering. And if there's a failure, we're going to retry immediately. So I'm going to come and click Create. And it begins to create the subscription for this topic. Now you can see we have the opportunity to view messages. So if I click View Messages and I click Pool, you'll see that right now we have no messages. There's no messages being sent to this topic. So in order for us to do that now, we have to go and create a change in that cloud storage account that's tied to this topic. So let's come up to Cloud Storage. Come into your Cloud Storage console. Find your bucket that you tied the topic to. Click Upload Files, and let's just upload a random file to the bucket. Once it's done and created, let's come back to our PubSub console one more time. Once we're back into our PubSub console, let's click our cloud topic that we created earlier. Now let's come up to the top and click View Messages. Select a Cloud PubSub subscription. So in our case, it's going to be the Richard Cloud Storage or whatever you named yours. Now I'm going to click Pool. So I should get a message now because we made changes to that cloud storage bucket. So that would have pushed a message out to PubSub. And now we're going to pool it as a subscriber. So if I click Pool, you'll see it's pulling. Now you'll see there is a message. So if we come over and view the whole row content and click the drop down button, you'll see the bucket ID is there, the event type is there, the object generation, and the whole payload format is there as well. So by uploading to that storage account, that published a message to PubSub, which us as a subscriber pulled back down and viewed. So I hope this video showed you how to integrate your cloud storage account with PubSub notifications. So in this course, we've examined implementing Google App Engine, or GAE. We did this by exploring Google App Engine and its feature deprecations, installing SDKs for Google App Engine, and setting up a Cloud Run environment. We also took a look at deploying to App Engine and Cloud Run, and deploying Cloud Functions, deploying an app that receives Google Cloud events, and setting up PubSub Cloud Storage notifications. In our next course, we'll move on to examine managing Google App Engine. In this video, I'm going to demonstrate how to create a different version for your App Engine application. So I'm going to create a new App Engine service, and then I'm going to deploy a new version of that service, and we can take a look at how it looks in the console and the two differences between the two different versions. So once we're in our Google Cloud Platform and we're under our appropriate project, let's come up and under Search Products and Resources, let's type in App Engine, and let's click the App Engine product page. We're brought in to our App Engine product page. First thing we want to do is come over to the left-hand side and click Services. You may not have any services running. I have the default service running, but we're going to create a new service and then another version of that service. So I'm going to come up and I'm going to click the Activate Cloud Shell. That's going to open up my shells window down below, and I can get full access to a bash shell to run my commands for Google App Engine. So you can use any app of your choice. I'm just using a simple Python hello world. So you'll notice that I'm under my home directory, and I'm going to go into my Python app directory. So for you, this can be whatever application you want to deploy. I just changed the application and made the printout specify version 2, and that's the only difference I made to the application for purposes of this video. So if I do an ls in here, you can see I have two folders, Hello World and Hello World version 2. These are two applications. Like I mentioned, they're both in Python. Hello World just sprints out Hello World. This is the Python application. And Hello World version 2 just says Hello World. This is the Python application version 2. So I'm going to come into my Hello World folder. So I'm going to do an ls, and let's take a look at what's in this directory. So I have my app.yaml file, and then I have my main.py, or my main Python application. I also have a test Python application as well. So App Engine is going to look for the YAML file to create the environment and the Python file to create the application. So I'll go ahead and clear my screen, and I'll type gcloud app deploy. It gives me an overview of what it's going to deploy, the source, my target project, my service, and my version, and the target URL. Asks me if I want to continue. I click Y, and it uploads the files to the Google Cloud storage. The file upload is done, and depending on if your application has already been deployed before, will really determine how many files get uploaded. But as long as the file upload finishes successfully, then the file is up. Mine uploaded 0 files because it was already uploaded. One time before, I had already uploaded this application and deployed it. So now, when I deploy it again, I don't need to upload the file. Yours will be different if it's the first time you've uploaded that application. Now you can see that it successfully deployed Service 2. So if I come back up under Services, and I just click back out to my dashboard and then click back into Services again, you can see now that I have a new service called Service 2, and it has one version. So if I click Service 2, it brings me to the service page. Hello World, this is the Python service. So this is version 1. Now we're going to update this service with a new version. So I'll come back into my console, I'll clear my Cloud Shell, and now I'll do a cd ... and I'm going to come in this time, go into Hello World version 2. So if I look in this directory, I go into Hello World version 2, you'll see I have app.yaml, main.py, and main test. So everything is exactly the same, just the printout on the website is different. What I want to show you is under the app.yaml file. So if I do a cat app.yaml, it prints out. Now look, it tells you the runtime is Python, the API version is 1, but you see service. So service 2. On the first time I deployed it was also service 2. So App Engine looks at this and says, okay, this is service 2. I already have one version of service 2, so this must be version 2. So this looks good. I'm going to say gcloud app deploy, hit enter. I get all my information again, the target project, the target service. I select Y to continue. It uploads one file this time because it's a different file. I made a change to that file. And that's really how you know that it's a different version, because there should be some changes made to it that makes it a different version. So the file upload is done. It updates my service. And once it's complete, we should be able to look in the console and see now that we have 2 versions of the service. Now you can see that it updated the service. It's complete. I'm going to close my Cloud Shell. I'm going to come back out. I'm going to come down and I'm going to click Versions on the left-hand side. So now we can see both versions. Version 2 is serving. Version 1 is not serving, right? So as soon as you update a version, it receives the traffic unless you set up some traffic migration or some traffic splitting. So if I click version 2, you'll see Hello World. This is the Python service version 2. If I come back to my versions again and I click the first version, you'll see it says Hello World. This is the Python service. So I hope this video showed you how to deploy a Google app version and to be able to look at the versions and see the differences between them just by clicking in the console. In this video, I'm going to discuss traffic splitting amongst different versions of your services. So traffic splitting or incremental feature rollouts and the ability to add or remove parts of features without affecting the end user experience is another popular use case of the App Engine. So with this microservice architecture, developers have access to isolated containers that represent features of an application. These containers can be added, modified, or removed. Companies will use this to route incoming traffic to different versions of the application. So for A/B testing, or to do incremental feature rollouts to update faster, and to isolate bugs without the risk of causing a system-wide crash. Traffic splitting will take your incoming requests and split them amongst the different versions, according to a distribution that you specify. So to enable traffic splitting, once we're in the Google Cloud Platform, come under App Engine and go to the App Engine dashboard. Once we're in the dashboard, come over to the left-hand side and let's click Services. And we'll take a look at our services. So I'm going to use Service 2 as my example. You can use any application that you have as long as it has at least 2 versions. So I'm going to click my service and I'm going to look at what the actual version is pointing to right now. So once I click my service, I see it says Hello World. This is the Python service version 2. So that's the latest version, and it sends all the traffic to that latest version by default. So I'm going to come back to my console and I'm going to click versions. So under versions it says 2. I'm going to click the 2 and I can see both of my versions. So you can see the version, the status, the traffic allocation, how many instances is allocated, the runtime, the environment, and if we scroll over, we can see the size, when it was deployed, and any tools for diagnosing like log files. So if I come back and scroll back over, let's just take a look at version 1. So if I click version 1, you can see it just says Hello World. This is the Python service. And if I click version 2, it just says this is the Python service version 2. So our goal now is to split the traffic between 2 different versions. So I'm going to highlight the 2 versions that I want to split the traffic between. So I just click off the checkbox next to the version name, and I come up to my More Actions. It's the 3 dots, and I click it, and then I click Split Traffic. So once I click Split Traffic, I'm brought into my Split Traffic console, and it gives me 3 options. I can split traffic by IP address, I can split traffic by cookies, or I can randomly split the traffic. IP address splitting is easier to set up, but it's less precise and it gives less detailed statistics. So if you ask for 5% of the traffic to be delivered to an alternate version, you may get a range of 3 to 7%. Because it's the easiest to use, you can see it's the default version in the console. IP splitting requires less effort to manage because it's based simply on a user's IP address. So when an application receives the address, it hashes the IP address of that request, and then it hashes it to a value between 0 and 999, and that value will determine which version a user is routed to. So it's ideally used to stick users to versions, but it has some significant limitation. IP addresses are randomized, right? They're independently assigned to versions. So this resulting traffic split will differ somewhat from what you specify. IP addresses change, so they're reasonably sticky, but they're not permanent. If you're connecting from cell phones, you may have an IP address change multiple times throughout one single session. So as a result, that user is going to have an inconsistent experience. And internal requests may not work. So requests sent to your app from outside of Google's infrastructure will work normally, but requests sent from app to app are not sent to a version because they all originate from a small number of IP addresses. So it applies to any traffic between the applications within Google's cloud infrastructure. That brings us to splitting traffic using cookies. So if you need to send requests between applications, use cookie splitting instead. That works by using HTTP cookies to assign users a value between 0 and 999. This approach makes it easier to get an accurate assignment of users to versions, and we allow smaller slices of traffic. There are also some limitations, so cookie management is required for mobile or desktop apps, and there's some extra additional requirements to make it work. So if I can split by IP address, I just select IP address. I can come down. You'll see I have two different versions here. If I had multiple versions, I can select different versions. And you'll see the scroll bar. So I can adjust this bar and you can see the allocation change. So right now, the bar is in the middle and the allocation is set to 50% and 50%. So version 1 will get 50% of the traffic and version 2 will get 50% of the traffic based on the user's IP address. I can change this to cookie. All the traffic allocation stays the same, or I can make it random. So what this does, it gives you a random version, but it's in line with the allocation. So if I go and I click the endpoint for my app, there's a 50% chance that I could randomly get version 1. There's a 50% chance I can randomly get version 2. This is when we don't really care what version a person hits. But if we want to tie users or services to versions, we need to split the traffic by IP address and cookie. So for the purposes of demonstration, I'm going to leave it on random and I'm going to click Save. It'll update the traffic splitting settings, and then we can hit the IP address of the application to see how random the traffic is actually split. You can see the traffic split settings have saved successfully. So I'm going to come back up to Services, and I'm going to click the service name. And that should bring me to either version 1 or version 2, right? We have a 50% chance. So once I click the service name, I'm brought to Hello World. This is the Python service. So this time I hit version 1. If I refresh, version 2. I refresh again, I get version 2. I refresh again, I get version 1. So it's a 50% chance each time on what version I get. If I selected IP address or cookies, this would never change. I would be tied to one version until my IP address changed. So I hope this video showed you why you want to use traffic splitting, the different options available to traffic splitting, and how to actually implement traffic splitting into your Google App Engine application. In this video, I'm going to discuss and demonstrate migrating traffic between versions of your application. So traffic migration will switch the request routing between the versions of your service. So it'll move traffic from one or more versions to a single new version. So this is how we kind of deploy new versions and migrate our traffic over. So we kind of got two options. In the standard environment, we can route requests to a target version either immediately or gradually. So gradually would mean that it would invoke a warm-up request. And by default, warm-up requests are disabled and traffic is migrated immediately to a new version. So if you want to gradually migrate your traffic, there are some configuration changes you have to make in your application and in your YAML file. So you need to add a warm-up request to your application. So let's take a look at a warm-up request. I'm going to expand my Cloud Shell. If yours is not open, you can come up to the top and click Activate Cloud Shell. And in my Go project, I'm going to cat app.yaml. And we take a look at app.yaml and we scroll up. So we can see the inbound services element is in our configuration file. So this helps us avoid latency and this enables warm-up requests. So you need to have the inbound services warm-up element in your configuration files, and your handler must reference the warm-up URL. So this is the changes you must make in your app.yaml file. So I'm going to come out, clear my screen. I'll type in cat warmup go, and let's take a look at the Go application itself. So if we scroll up all the way to the top, we can see that we have an App Engine warmup request is used to create a new instance. And you can see the function handler is the _AH warmup that we used as our URL trigger in the actual YAML file itself. So you got to have this code in your Go application, and it must be referenced along with the inbound services element in your configuration file. And you can get all this code from the Google App Engine documentation. So at this point now, I'm going to close my Cloud Shell, and I'm going to come back into my App Engine console, and I'm going to come over to versions. So I have two different versions running. I have version 1, that when I click it, it says Hello World. And I have version 2, and when I click it, I get Hello Universe. Currently, all my traffic is going to version 2, but hypothetically, I just noticed a bug. So it's not a massive bug, but it's something that I want to rectify. So I want to roll back to the previous version. So first thing I want to do is come over to version 1 and check the box next to the version name. And then come out to the top and click Migrate Traffic. So you'll see a pop-up that says Migrate Traffic to version, and it gives the actual version 1 name. And it says migration will take a few minutes as new instances are created to match the current traffic load. So we know at this point now that we are actually gradually moving over. Our application services won't be interrupted. So if I come down to show advanced options, I can click the button that says force route all traffic to the new version immediately. So we won't do gradual traffic migration, we'll do immediate traffic migration if I click this box. So for the purposes of demonstration, I'm going to go ahead and click it, and I'm going to click migrate and watch how all the traffic gets routed. So if I come up and click refresh, immediately I am now serving all traffic back to version 1 again. But what if I only want to gradually move traffic back? So in this case, I'll come up, I'll click version 2. Now I'm going to gradually migrate the traffic back to version 2. So I click migrate traffic. This time under advanced options, I make sure that the force route traffic is on check. And I come down and I click migrate, and this should create the gradual migration. And we should see a different behavior this time. So if I click refresh, you'll see now that it's at an 80-20 split. So it's gradually moving. At this point last time, the traffic allocation was already 100% on the new version. Here, we're gradually moving. Now we're at 60-40, right? 60% for the target. And now we're at 100%. So it gradually moved that traffic over to a newer version. So I hope this video explained migration of traffic to new versions and the different types of migration that you can perform, either gradual or immediate, right? And we have to know that in the standard environment, you can do both, but in the flexible environment, gradual traffic migration is not supported. It's also important to note that if you immediately migrate traffic to a new version without any running instances, your app will have a spike in latency. And it's good to gradually shift the traffic over to a new version and gracefully move everyone over to the new version of your application. In this video, I'm going to show you how to map your custom domain to your Google App Engine application. So once you're in the App Engine console, I'm going to come over and I'm going to look at services, and I'm going to select a service to point my custom domain to. So I'm going to use service 2. So once I click service 2, it brings me just to a simple hello world. This is the Python service page. So if you don't have a domain, you're going to have to purchase one. You can use any domain name registrar. If you use Google Domains, the domain is automatically verified for App Engine, and you won't have to go through the domain verification process that we're going to have to go through today. If you use cloud load balancing to route traffic to your App Engine app, it's recommended that you map your custom domain name to the load balancer instead of directly to the application. But the beauty of having your custom domain is that, like, nobody wants to have a URL that looks like service2.project-70969. It's just a handful. So I'm going to come back to my console, and I'm going to set up that custom domain so that they can just type in www.learnthecloudnl.com. It's much easier to remember. So I'm going to come in under Settings on the left-hand side, and I'm going to come up to Custom Domains. So I'm going to click Custom Domains, and here's where I can add my custom domain. So if I use a custom domain, Google will provide a managed auto-renewing SSL certificate for security. So if I don't have a new one, I can register a new domain right here. I have a couple of custom domains, so I'm just going to go ahead and click Add a Custom Domain. Once I click it, it's asking me, what domain do you want to use? So I'm going to use learnthecloudnl.com, but you could also verify a new domain. So if I click Verify a New Domain, and I say richardkspencer.com, now I can verify the richardkspencer.com domain. So if I click the Verify button, it brings me into my Google Webmaster Central, and it's asking me to verify the ownership of richardkspencer.com. So the verification method in this case is the domain name provider, and then it asks you to sign into your domain name provider. It automatically selected GoDaddy for me because it knew it was a GoDaddy URL, but sometimes you may have to expand the drop-down and choose your domain registrar. And there's a big list to choose from, so yours should definitely be there. I'm going to leave mine on GoDaddy because that's where I purchased my domain name, and I'm going to click Verify. It pops up the GoDaddy login. I fill in my username and my password. I click Sign In, and now the verification process will begin. It asks you to click Connect to authorize Google to enable the service domain verification. I'm going to go ahead and click Connect, and I wait. The verification begins, and it takes about 30 to 45 seconds to complete. Once the verification is completed, it says it has been successfully verified. I click Go to Property Verification. Here's where it tells me I can add more properties or I can view the verification details. So if I go to richardkspencer.com, click Verification Details, you can see that the verification was successful, right? So it used the method of a DNS TXT record. It comes down, it picks up the verified owners. So right now, I know that this domain name is now registered. So I'm going to go back to my console, and I'm going to click Refresh Domains. You can see now it says Successfully Verified Ownership of richardkspencer.com. I click Continue. It asks me to point my domain to project 709-695-3230, and Google will add a free auto-renewing SSL certificate to your application for security. So the following domains and subdomains will be mapped: www.richardkspencer.com and just richardkspencer.com. I'm going to click Save Mappings. Then we move on to Section 3. We click Continue, and it asks us to update our DNS records to enable security. So at this point now, I have to make the DNS changes in my GoDaddy console. And that should take about 24 hours to take effect. So I click Done, and you can see that these custom domain names now are provisioning, and it's making the SSL certificate for us. So once I update my DNS records at GoDaddy, the App Engine can connect and see that the DNS records have been changed, and then our domain is easily mapped to our Google App Engine application. In this video, I'm going to talk about SSL certificates for your custom domains in the App Engine. So SSL support for your App Engine app is much more advanced than the basic SSL by offering globally distributed SSL endpoints and built-in load balancing to help serve your app securely, reliably, and quickly. So by default, HTTPS connections on your custom domains will be enabled automatically using the managed SSL certificates. You can also use your own SSL certificate. So let's take a look at both. So once I'm in my App Engine console, I'm going to come down to Settings. I'm going to click Settings, and I'm brought to my application settings screen. So from here, I'm going to come up and I'm going to click Custom Domains, and you'll see my custom domain is here. So as you can see, richardkspencer.com and www.richardkspencer.com. Neither of these custom domain names are using any type of SSL security. So if I navigate to http://richardkspencer.com, I'm greeted with a page that looks like this. It's just a hello universe, it gives the uptime, and you can see it's a not secure connection. It's only an HTTP. So let's go about fixing that. So I have two options available. I'm going to highlight and click both of the custom domain names, and you'll see a new box highlight at the top, and it says Enable Managed Security. So Enable Managed Security will create our SSL certificates for us that the Google App Engine platform will manage and apply to my custom domain name for me. So Google does all the work in this case. So in this case, we want to look at enabling the managed security so we can get that Google provided and Google managed SSL certificate. So I'm going to come up and I'm going to click Enable Managed Security. And you'll see right away under the SSL Security tab that it changed from none to Google Managed, and it's auto-renewing. So now it's going out to my domain provider and applying this certificate. And sometimes this can take a little bit of time. So it's just a minute to sit back and wait. But don't be alarmed because, again, sometimes this takes a little while for it to actually apply and for you to be able to see it. So now you can see that it is complete. Both custom domain names have SSL security enabled and it's Google managed. So if I go to the secure site of richardkspencer.com now, I get the Hello Universe, and I can come up and I can click the lock, and I can come down and click certificate. It tells me I have a secure connection, and it's issued by GTS. So it's a Google Certificate Authority. So now I know that this is a Google managed certificate, and I have a secure connection. If I wanted to use my own SSL certificate from another certificate authority, I have to come and select both of the custom domain names and click Disable Managed Security. You'll see then that it quickly changes to no SSL security. And at this point now, you do not have a secure site. So to upload our own SSL certificates, you come up and you click SSL certificates, click Upload a new certificate, and now you'll see that you have to add a new SSL certificate. So you have to upload a PEM encoded public key certificate. So I'm going to click Choose File. I'm going to find my certificate, that CRT file, and I'm going to upload it. Then it asks for the unencrypted PEM encoded RSA private key. So I click Choose Files, and I take my private.key. Now these were from my certificate authority. Your certificate authority, whatever one you use, will be able to provide you with these files as well. So if I go ahead and click Upload, now it asks me, do I want to enable SSL for the following custom domains? I select both, and I click Save. Now you'll see that it begins to update. I have a new certificate listed, and if I come back to custom domains, you'll see now that it is using my new certificate, and it gives the certificate ID. So if I go to my website now, I should be able to see that it is a secured website, but now I'm using a different certificate and a different certificate authority from OpenSSL. So previously, when we looked at the certificate and we saw it was a Google certificate, now when we look at it, it should be an OpenSSL certificate. Because previously I did Google managed, now I'm using my own SSL certificate. So let's go take a look. And now, as you can see, richardkspencer.com is now secured with the certificate. So if I come over and I click the lock, I can see that it is a secure connection. And if I come down and click the certificate, we can see the certificate that I just uploaded manually. So it's issued by 0SSL, RSA Domain Secure Site Certificate Authority. You can see it was issued to richardkspencer.com. So I'll go ahead and click OK. So I hope this video showed you the importance of an SSL certificate in your Google App Engine application and the different types of SSL certificates that you can implement, whether it's a Google managed SSL certificate or a self-managed SSL certificate. In this video, I want to talk about and demonstrate some way to manage your app resources. So once you're in your App Engine console, on the left-hand side, you'll see we have plenty of options that we can look at. A lot of these options have direct correlation to how you manage your app resources, and some of them give you information on how your app is actually working. So the first thing I want to take a look at is the instances page. So if we come over on the left-hand side and we choose instances, we're brought into our instance page, and the first thing that we see is a dashboard. So this gives us insights on the version and the metric that we choose. So under version, I can choose current version or previous version. And if I choose the summary dropdown, I get a bunch of different metrics that I can choose from as well. So if I just look at summary, I can come down. I can see right now the total requests are in orange and the client 4XX responses are in purple. So if I hover over at any type, you can see in count per second the total requests and the client 4XX responses, and they match in this case. I can come back up. I can choose traffic, and I can look at more traffic latencies. So bytes received and bytes sent. I can do this over an hour, 6 hours, 12 hours, right up to 30 days. Other metrics is utilization. So if I look at utilization, this is megacycles per second. So if I hover over each area on the line, I can see the total CPU and the API calls CPU. I can come back up and I can look at instances, memory usage, memcache operations, and memcache compute units. I can also scroll down and look at my instances and see the instances ID. We can also see that it's auto-scale. I can click instances and delete them. I can also roll over to the right-hand side and see the QPS, the latency, how many requests each one received, any errors, memory usage, start time, and the availability. So it's a good way to take a look at my instances. I can also come and do a security scans. So if my app is front-facing like it is, I can come up and click New Scan and create a new scan for my URL. So it asks me for the starting URL. So I give it the URL of my application. If I want to exclude any URLs, I can. In this case, I don't want to. I'm going to go ahead and click Save. And now the scan has been created, but not run. So you'll see it gives you the starting URL, the authentication, what the user agent is going to be, the maximum scan speed, risk level, and should we ignore any status errors. So I'm going to go ahead and click Run Scan. And now our scan is starting to run, and it's going to test these URLs for any vulnerability. You can see it updates itself as it goes, so it's 17% finished. It found no vulnerabilities. If you come up and click URLs crawled, you can see the URL that we specified and its HTTP method of GET. And if there's any details, you'll see them here. And these are what we set up originally. So if I come back and click Results, you'll see it's now 17% finished. So while this is finishing, I want to show you a couple other things in the Google App Engine. So let's go back to the Google App Engine console. I'm just going to come up to the search bar and type in App Engine. And that won't affect your scan. Your scan will continue to run. There's a couple other things that we should look at when it comes to managing your application. One of these are firewall rules. So right now we have one default firewall rule. And that default firewall rule, if we click it, gives us an allow all IP ranges. So I can edit this firewall rule and click deny, and that will deny all traffic to my application. Since this is a web application, this is not what I want to do. So I'll just go ahead and click save and leave it on allow. We have quotas. So quotas show you your daily usage against your daily quota and your per minute quota. You can also click show resources not in use, and it includes all your resources that you're not using. The last thing I want to show you is memcache. So memcache is used as a cache for your application, and it can have a significant impact on how efficiently your data is cached by the servers and the browsers. So you want to use memcache efficiently. Use batch calls for get, set, delete instead of a series of individual calls. Shared memcache is free to use, and it's commonly used to speed up these data store queries. So if a lot of the requests are the same, and they make the same query with the same parameters, and there's no change in the data, then that application can and should cache those results in memcache to speed up the performance. So let's come back up to security scans again and check on our security scans. Once we click it now, we can see that 3 URLs were tested. There's warnings generated. So if I click the scan name, you can see that the scan discovered an unexpectedly low number of URLs. This is sometimes caused by complex navigation features. It's just that I don't have a big web application running. It's just one page. Other than that, there's no vulnerabilities found, and it took 2 minutes and 34 seconds to run the test. So I hope this video showed you how to manage some of your resources, how to view the metrics, how to run security scans, and when to use memcache to cache some of the queries for your application. In this video, I want to discuss auto-scaling in App Engine and the various settings that you can configure in your app.yaml file to change auto-scaling settings to your needs. So far we've only deployed our services. We haven't really talked about scaling them. But the App Engine has quite a few scaling options that we can fine-tune to fit our needs. So let's look at the default option, and that's one of the main features of App Engine, is auto-scaling. So automatic scaling is automatic. It's the default. App Engine will decide when to turn on new instances for you based on a few metrics. Some of these can be concurrent requests, or pending latency, or the number of instances that can idle at any time. These all have default settings, but we can change them in our app.yaml file. So first thing I want to look at is our app.yaml file. So let's come up and click Activate Cloud Shell, or wherever your app.yaml file is. Mine's in the Cloud Shell, and it's in the Go directory. And if I do a listing, I see app.yaml. So if I do a cat app.yaml, so when we look in our app.yaml file, we'll see an element called automatic scaling. So in this case, we're scaling based on idle instances. So we're saying the minimum number of idle instances should be 2. The maximum number of idle instances should be 3. Because these App Engine instances are only chunks of CPU and memory rather than a full virtual machine. Because of this, App Engine Standard provides a way for you to decide the minimum and maximum number of instances that can sit idle, waiting for requests before they're eventually turned off. This setting is a bit like choosing how many buffer instances to keep around that aren't actively in use. So if you set the minimum idle instances to 2 and the maximum of 3, you'll end up with 1 busy instance and 2 idle instances that sit around doing nothing except waiting for more requests. So there may be a better way to do that. On the other hand, if we set the minimum and maximum idle instances both to 1, App Engine will turn off instances until there's exactly 1 sitting idle waiting for requests. So in that case, you'd have 1 busy instance and 1 idle instance. So we have ours set up as 2 min idle instances and 3 max idle instances. But we can also do this based on pending latency. So when we make a request to the App Engine, Google's front-end servers handle the request and route it to a specific instance running in the service. App Engine keeps a queue of requests in case some of them aren't ready to be handled yet. And if no instance is available to respond to a given request, it can sit in a queue for a while until an instance actually does become available. Because App Engine can turn on more instances if your request is sitting in the queue for a long time, it seems like a good idea to turn on an instance. Doing that will help get through the queue of work more quickly. So in order to set that up, we'd have to change our automatic scaling. So we'd come back into our app.yaml file, and this time instead of using min idle instances and max idle instances, we can remove these and we can change it to min pending latency to be 5 seconds and max pending latency to be 10 seconds. So I hit Control Save, and now when I redeploy, it's going to take these automatic scaling parameters instead. We can also use a max concurrent request. So I can use the auto scaling and I can use it as max concurrent request equal to 10, and I can save it. So in that case, we're only looking at the concurrent request. So that's 3 ways we can automatically scale. We can scale by pending latency, we can scale by idle instances, or we can scale via concurrent requests. And these are all ways that we can automatically scale. So if I come out now and I do a gcloud app deploy, I click authorize, and now it's redeploying a new version. So if I come into my dashboard and I minimize my Cloud SDK, and if I come down to instances, and if I scroll all the way down, you'll see right now I have 5 instances. That's how I set it previously before I just made that change. So I'd expect to see some instances changing due to the change I made in my automatic scaling. Before, I had it set to a min number of instances, which was 5, and a max of 100. And then I just changed my metric to max concurrent requests of 10. So we should see some changes in the number of instances. Now when I refresh instances and come down, you'll see it automatically scaled back down to 2 instances based on the new metric of max concurrent requests. So I hope this video showed you why autoscaling is important for your application and how to configure different settings for automatic scaling, whether it's idle time or concurrent requests or just pending latency, right? But all these metrics can be used to configure your autoscaling in the Google App Engine. In this video, I'm going to show you how to set autoscaling parameters with the API Explorer. So if you use a Cloud SDK tool to deploy and build your application, you can set autoscaling parameters in the app.yaml file. However, if you're deploying using the app CFG, the app config tool from the App Engine SDK, you can't set those autoscaling parameters in the app.yaml file. So you would have to remove it from the app.yaml file and use what we're going to use, and that's the API Explorer user interface. So I'm in my Google Cloud platform, I'm under my project, and I'm in the App Engine dashboard. So the first thing I want to look at is under versions. So I'm going to go ahead and click versions, and I just want to look at my application before we make any updates to it. So my one version right now is running 0 instances. If I come to the left and click instances, you'll see no instances. So I'm going to come back to versions. So no instances running tells me that I have a min instances equal to 0 somewhere along the way because I don't have any minimum instances running, right? So if this was an instance that should be serving and have an instance up all the time, then I'd probably have min instance equal to 1. Right now it's set to 0. So we're going to go ahead and change that in the API Explorer. So we need 3 things. We need our project ID, we're going to need our service, and we're going to need our version. So I'm going to flip over to the API Explorer page. This page can be found under the App Engine Admin API reference. You can also Google it and find it very quickly as well. So we're going to run the Admin API. So you can see here under the standard environment, automatic scaling options in the standard environment. We can specify the min idle instances, the max idle instances. For standard scheduling, we can set the max instances, the min instances, target CPU, and target throughput. So the first thing I need is my app's ID. So that's going to be my project ID. So my project ID, in this case, is xvector319919. My services ID is going to be default because it's the default service. And my version ID is going to be my current version of 202.10715T192259. So I've specified my project ID, the service, and the version that I want to run this API. So my update mask is here. I've chosen automatic scaling, standard, scheduler, set, the minimum instances. I can also add in maximum instances, target CPU, and target throughput. I just have to add a comma after each one. In this case, I'm going to leave it on min instances. I'm going to leave the rest of the parameters empty. And then you'll see the request body. So here, I'm going to paste in my request body, but you could also just click the add request body parameters, and you can use the drop-down menu to select and build your request body. So my request body looks like this: automatic scaling, then the standard scheduler settings, and then min instance 1. I can change that to 10. Come down, I choose credentials, so Google OAuth 2.0 or an API key. I'm going to use the Google OAuth. You may get a pop-up and ask you to authenticate your Google account. You can go ahead and authorize it and then execute it. Come down, click the blue button to execute. I get a 200 return back. Tells me the type, the method, the insert type, who the user was, and the target. So now I should have 10 minimum instances. So let me go back over to my App Engine application. So I'm back into my dashboard. If I come into instances and do a refresh, now you can start to see the instances being scaled up for that version. So if I come back to my version again and click it, I get the hello world. This is the Python service. And I come back under versions again, do a refresh. Instances are starting to update. It's not instantaneous. It's showing 5 under versions. But if I come under instances, it's actually about 8. And it's still scaling up to reach the minimum of 10. So I'm going to come back to the API Explorer again. And this time I want to show you how to set more than one parameter in a request. So I'm going to leave my application the same, my services the same, and my version the same. But I'm going to change my default update mask now. So instead of having just min instances, I'm going to have max instances, min instances, and target CPU utilization. So I paste in my update mask. So now you can see the update mask has the standard scheduler setting for max instances, comma, then it has the setting for min instances separated by another comma. We have the setting for target CPU utilization. So now we have to change the body request because we are adding more requests to the update mask. So I scroll down to request body, and I'm going to paste in my request body this time, and I'm adding in max instances and min instances with a target CPU utilization of 75%. You can change these to whatever fits your needs. If I come down and click execute, I get a return of 200, which means it successfully worked. And now those settings are going to be updated to my App Engine. So I hope this video showed you how to go about using the API Explorer to change automatic scaling settings for your Google App Engine application. In this video, I'm going to show you how to create and view a Cloud Run service. So once you're in the Google Cloud Platform, up under Search Products and Resources, just type in Cloud Run. Come down and click Cloud Run, and we're brought to our Cloud Run console page. So Cloud Run allows us to run containers in a fully managed environment. Right? So we don't have to worry about the underlying infrastructure that runs these containers. So I'm going to go ahead on the bottom and click the big blue button that says clicking Create Service will enable the Cloud Run API. So I'm going to go ahead and click it, and it brings us right into an area where we create a service. Right? So it enables the API and creates that service for us. So the first thing I need to do is give it a service name. So I'm just going to call it Web Server. with a few random numbers at the end, and leave my region as US Central 1. I click Next. From here, it asks me, do I want to deploy one revision from an existing container image or continuously deploy new revisions from a source repository? In my case, I'm just going to deploy a simple sample container image. So if I click Select, it brings up the Google Container Registry. Under Demo Containers, I can expand it and click Hello. And I click Select. You can see the URL populate. You can use that URL as well and pull that container image down. Under Advanced Settings, you'll see the port that we're going to serve on is port 8080. All of our capacity and CPU allocation and request timeout, maximum request per container. So all your settings are set here as well well as your auto scaling parameters. So I'm going to leave all that the same. I'm going to click Next. Then it asks me how I want to trigger this service. So it's just a simple web server. I'm just going to allow all traffic. I could just allow internal traffic and traffic from a load balancer, or just internal traffic only. Since I'm allowing all traffic and it's external traffic, under authentication, I can click Allow Unauthenticated Invocations. Because it's front-facing public web server, we don't need to require authentication. So once I'm happy with my settings, I'm going to go ahead and click Create. And now we wait for the web server to be created. From here, you have a bunch of different things we can look at. So you know it's been successfully deployed because we've got our green checkbox. First thing I want to look at is metrics. So if we come over and click Metrics, you'll see all the metrics that can be reported on. Your reporting frequency can be between 1 hour and 30 days. Now, right now, we don't have any data right away. It's still populating, and we just deployed the actual application. But you get metrics like request count, request latencies, container instance count, billable container instance time, and container memory utilization. We can also come up to revisions. Here's where we can deploy multiple revisions. We can also tie that in to setting up continuous deployment. Right? So we can set this up with a repository. Anytime we make a change and upload it to the repository, Cloud Run performs continuous deployment, pulls down the new image, and safely deploys it out. We have log files, so we can take a look at all of our log files. It shows us things like when the Cloud Run service was created, when it was started successfully, and we can expand these logs details and take even bigger look at what entails inside these logs. This is great for troubleshooting and just getting a good insight on what's actually going on with your service. Under triggers, you'll see the ingress settings and the authentication settings. We can also add an event arc trigger. So if we click Add Event Arc Trigger, under the new Event Arc Trigger pop-up that comes up, we can pick an event. So what events can we use to trigger this Cloud Run service? So it could be pub sub events, BigQuery, Cloud Build, Cloud Data Store, right? So we can run container instances that are triggered from other Google Cloud Platform services. I'm going to click Cancel. I'm going to leave it alone. It's just a web server. Under Details, we can see our region. We can see our URL. We can click our URL, and it shows us what we deployed. It was just a container image. We go back to our console. We can see binary authorization if we want to enable it. Under YAML, we can see our YAML template that all of this is built upon. And under permissions, we can view our members, or we can view the roles that our members make up. So we're going to come back under revisions. And under revisions, I just want to look at a couple little things that should be noticed. One of these is the image URL, right? So this is the URL to our image. And if we were using continuous deployment, you would see a build and you'd see a source as well. You can also see your capacity settings that we set up. So this is a good go-to. to quickly take a look at things like your URL, the port, the source, and any capacity that you're running all at one blink of the eye. So you can see it all in one place. So I hope this video showed you how to deploy a Cloud Run service, how to view all the options in the Cloud Run console that you can use to fine-tune and make your Cloud Run service really work for you. In this video, I'm going to show you how to deploy a new revision of a Cloud Run service. Now, there's a few things we need to discuss about revisions, right? A few considerations to take in. First of all, you can specify whether a new version will receive all the traffic right away, none of the traffic right away, or some of the traffic that you gradually roll out to a new version. You can split traffic between several versions, and you can roll back from a version. You have the opportunity to use revision tags to test a revision that's not serving traffic, and you don't need to manually delete revisions. You can if you want, but it's not necessary. And there's a maximum of 1,000 revisions per service. So I'm going to go into my Cloud Run service called Web Server, and from here, I'm going to look at my revisions. So you'll see a tab called Revisions. I'm going to go ahead and click the Revisions tab. Right now, you see I have one revision. It has 100% of the traffic, and it was deployed 19 minutes ago. But there's a few things I want to change. I want to change the port, and I want to change the capacity. I want to bring up my CPU and my memory allocation. So I'm going to come up, and I'm going to click Edit and Deploy New Revision. And then from this page, I create changes or revisions to my service. So I'm going to leave the container image alone, but I am going to change the container port to port 80. I also want to scroll down, and under capacity, I want to increase the capacity to 1 gigabyte of memory and 2 virtual CPUs. And I'd like to change the request timeout from 300 seconds to 600 seconds. And now, since I've increased my capacity, I'm going to double my maximum request per container. Under auto scaling, I want a minimum of 1 instance and a maximum of 50 instances. Next, you'll see a checkbox. Do I want to serve this revision immediately? So do I want 100% of the traffic to be migrated to this revision? I'm going to go ahead and leave it checked, and I'm going to click Deploy. This is going to deploy the new revision. So under revisions, you can watch it live. So right now, you can see that it's been deployed, and it's in the process of routing the new traffic. So now the new traffic has been routed. All the traffic is going to the new version that's just been deployed. But now you'll see I also have another option. This option is to manage traffic. So I'm going to click Manage Traffic. And right now, it's serving 100% of the latest healthy revision. I want to split that traffic 50-50. So I'm going to split 50% on the new version and 50% on the previous version. And I can just come down and assign this to 0 because I'm doing a traffic split. And now, when I click Save, I'm going to manage my traffic by splitting it half to the new version, half to the old version. So I click Save, and now we wait, and we should see our traffic be split evenly once the traffic routing process has been completed. And it's been done, and now we're split 50-50. I can take this one step further. I can make it 75 and 25. Or I can click Manage Traffic and make it 80-20. Maybe we just want to test a new revision on a small group of users. I can say 95 and 5. Click Save, and then we can come over and we can see the traffic load shift right in front of our eyes. It's 95 to 5%. So once I'm done, and maybe I want to delete a revision, I can click this revision, scroll all the way over to the 3 dots, manage the traffic. So I want to make sure I'm only serving 100%. to the new version and 0% to the version I want to delete. Once that gets updated and this version is serving 0% of the traffic, I can go ahead, click the three buttons again, click delete, and it will delete that version. Now, it's not necessary to delete these revisions. You can have upwards of 1,000. So I hope this video showed you how revisions work in the Google Cloud Run service. So in this course, we've examined managing Google App Engine. We did this by exploring using traffic splitting and traffic routing, mapping and securing custom domains, managing app resources. We've also looked at scaling configurations and parameters, updating app versions, and creating and viewing Cloud Run services and viewing revisions. Coming up in our next course, we'll look at implementing Google Cloud Storage.